All right, folks. Thanks for coming. We still, before we go, Happy New Year. I think this is my first video in the new year. The last video I posted, I started that before the new year. So I've been busy with something. But I promise to, get going soon. Anyway, we're still on polynomials. And we're gonna treat rational expressions. And rational expressions are polynomials. Yeah, you will see in a minute when I define what a rational expression is. Before I continue, please subscribe to my channel, like and share this video. If you have any question or comment, leave it under the video. Okay, so I'm gonna define what is a rational expression, and then from there we'll go on to the next things we have to do. All right, these are the stuff we will cover in this video. I'm gonna define what a rational expression is, and then I'm gonna show you how to simplify rational expressions, and then after that we deal with multiplying and dividing rational expressions, and then next we deal with adding and subtracting rational expressions, and then after that I show you how to solve equations involving rational expressions, and then finally I will solve some problems involving applications of rational expressions. So this video is gonna be long. Yeah, it's gonna be long, so I will do it in stages. I don't know when I'm gonna finish it, so it may take me a couple of days, but my target is to finish it before the end of weekend. Okay. All right, so let's go to define what is rational expression. All right, so now we're gonna deal with the definition of rational expression. Now recall from arithmetic, right? We have dealt with something similar to rational expression. You remember we have what they called rational numbers, right? Rational numbers, the same thing as fractions. Okay. A rational number is the same thing as a fraction. A rational number is the quotient of two whole numbers, right? A rational number is the quotient of two whole numbers. It's expressed like this here, A over B, where A and B are whole numbers, okay? And then A and B are whole numbers, and B cannot be zero. You're not supposed to divide with zero, okay? You remember that, right? So something like this basically is a fraction, but they call it a rational number. All right. Also notice this. In a rational fraction, A is on top, B is on the bottom. A is the numerator, and B is called the denominator. So we have the same thing in polynomials, okay? The quotient of two polynomials is called a rational expression. Pick up on that. Rational expression is where you divide one polynomial with another. It's expressed like this. Here, this is a polynomial. This is a polynomial. You divide the polynomial P with polynomial Q. Again, the same restrictions that is on when we define rational numbers over here. The same restriction applies here too. So Q cannot be zero. It cannot be equal to zero because then it will force us to divide with zero. You can't divide with zero. P and Q are also polynomials. They're all polynomials. So basically, you can't have a zero polynomial as the denominator. That's all that is saying. Okay, P of X is called the numerator. The same thing in you saw in a rational. You saw in a fraction. And this one is called denominator, okay? Denominator, okay. Alright. See, the same thing, the same idea. Alright. Alright, so that's the definition there. Make sure you understand that. Understand how you define a rational expression. It's just a quotient of a quotient consisting of two polynomials, or one polynomial divided by another polynomial. That's all. But the polynomial in the denominator cannot be zero. Alright, so remember that it can't divide with zero. See, the same idea as a rational number, okay? Alright, so let's I'm gonna give you some example now. Just give me a minute, I'll get you some examples. Here are examples of rational expression. X plus 3 over x minus 4. This is a rational expression, okay? Yeah, make sure you understand that rational expression, because it has because the one on top, the numerator is a polynomial, and that's a polynomial, okay? All right. And then look at another example. This is a rational expression. Yeah, this is a rational expression. That there is actually, yeah, that's a rational expression. And then this one here, this is a rational expression, okay? And this one here plus, let's say 6x to the power 2 minus 8x plus 2 divided by x raised to power 3. This is a rational expression, okay? It's a rational expression, okay? Why? Because this is a polynomial, and this is a polynomial dividing with a polynomial. This down here is a polynomial, that's up there is a polynomial, okay? And then look at another example. This one will surprise you. Let's say 4 over 5. This is a rational expression. I know it will confuse you, because this is also a rational number. But don't forget that 4, the numerator is a polynomial. That's a polynomial. A polynomial can be constant. Remember what they call a monomial. So in this case, a rational expression is the same thing as a rational number, okay? Rational number. Alright, so, and here is another example here. Look at this one. Look at this one, 6x, alright, squared plus 3 over 3x minus 2. This is not a rational expression. Why? Because this is not a polynomial. Anything under square root is not a polynomial, okay? It's not a polynomial. So the whole thing is not a rational expression. All right? So make sure you understand this, yeah. Why they are rational expression, why they are not why something is not a polynomial. If you understand it, then the rest of the stuff will be a little bit easier for you, okay? All right, just give me a minute. I'm gonna give you some principle we're gonna discuss how to simplify a rational expression. The first set of problems we will solve involve taking a rational expression and reducing it to the lowest term. So what does that mean? What does it mean to reduce a rational expression to the lowest term? Okay, here is the definition, okay? A rational expression is in lowest terms when the numerator and the denominator have no factor in common. They have no factor in common. Another way to say that, the only common factor they have is 1. That's all that means, man. If you look at the numerator, if you look at the denominator, they can't have any factor in common. Or if you look at it carefully, the only common factor they have is just 1. I will explain that more. But let me tell you how to reduce a rational expression to the lowest term. First, First, what you do, you factor. You factor, factor. You factor the numerator, and denominator. Okay, you factor them. You factor them completely. Okay. So once you factor them completely, then you divide. Okay, the second thing is divide. You divide. You divide the numerator. Okay, the numerator and the denominator. Okay. You divide them with all the common factors, okay? All the common factors, so as we go, you will understand this. Okay, so understand what it means to be in reduced term. It means they don't have any common factor. But then what happens to reduce it in common factor? One, you find all the common factors. You factor them. That's what you're doing. When you factor them, and then the common factors will show, and then you divide the numerator and the denominator with all the common factors. Just read this until you understand it. I'm gonna show you. I'm gonna give you some examples to demonstrate what I'm saying there. But there is something you already know. Remember when we did fractions in arithmetic, right? Let's say you have 6/3. You see that? Look at this. That can be written like this. It can be written like 2 times 3/3. And notice what happened. Notice that the numerator has 3 and the denominator has 3. So those are the common factors. See? So you can cancel them out. What do you get? You get 2. And once you get 2, it means that 1 is here, 1 is there. And see, 1 is the common factor. That's what this will help you to understand all that definition up there. To reduce something into lowest terms, the only common factor that we'll have is 1. Right? Or to say it in a different way, the denominator and the numerator will have no factor in common. You see over here, right here, look over here, they have 3 in common. So you cross that, and then it becomes 2. So the factor they have in common is 1. Because like I said, you can do this. It doesn't, it means nothing. You can cross that out. Okay, so make sure you understand that. And then generally, this is what I call, different books calls it different things. I call it a simplification rule. Okay, it's a general rule, but you know what it is. Simplification rule. So if you have let's say you have 2 polynomials, right? You have 2 polynomials, P and Q. Okay, these are 2 polynomials. Okay, there are 2 polynomials, right? P and Q. Let's say you have you write it like this, like a rational fraction, px over qx. Okay, of course we know that qx cannot be 0. We know that. That's one of the definitions. Let's say you write it like this, but let's say you multiply them with a common factor. Let's say k is another polynomial. A polynomial. Okay, don't forget k can be a constant. It can be 4, it can be 5, right? Then suppose you do k times px over k times qx. You see that, right? That's the same thing as px over qx. You see? So basically you factor this out. All right, so this is it doesn't look like it's important, but it's important. By the way, k cannot be 0, okay? Just like q cannot be 0. So make sure you understand this, man. This is the rule of the rule of simplification. That's how you simplify this. So you can go both ways. You can have p start with p x over qx. Sorry, and then you factor something. K over k. I'm sorry. So just look at it. Don't look at it from one way. You can go both ways. You factor it out, and then you have qx right there. You see? So you can go this way or you can go that way, okay? So make sure you understand that. Now, there's something that will go with this we'll learn from when we did exponent. You remember exponent? By the way, everything we learned in the past, everything we learned in the past will come to bear when you're solving this thing. Everything we learned about fractions, about factoring, about exponents, about polynomials, it will come together. You apply it here when you're solving problem here. Don't forget all that stuff we learned in the past. But I want to bring your attention to these two important rules from exponent because they will help you. We're gonna use it all over again. Remember when we did exponent, we said if this is a and then b, a times b, and then they have this thing here, exponent m, like that. Then you can simplify it as a with the exponent times b with the exponent. You remember that? That's a rule. I forgot what it's called. I think it's called product rule or something, or power rule. I don't remember which one. That's one. There is another one you need to recall. You keep in mind because it's very useful here. Let's say you have, I think they call this quotient rule. You have something like this, raised to power m, then it becomes a raised to power m over b raised to power m. You remember that, right? This is one of those rules in when we did the exponent. Go back and watch the video in the exponent, and don't forget what I said. If you have something like this, let's say you have let's say you have something like this, a m over something else, b n. You remember, you can write that as a m minus, I'm sorry, it has to be, it has to be the same base. Sorry, you have a n, then you can write that as m minus n. You see that, right? So make sure you understand that. If you don't understand any of this, go back to the video on exponents, okay? This will be useful as we solve problems, okay? So now what we're gonna do, I'm gonna show you a bunch of problems, to show you how to do simplification. Okay, I'll solve a bunch of problems in simplification using the stuff I showed you here. What is called simplification rules, okay? All right. Before I solve a bunch of problems, let me give you 3 examples of what, the way we're going to be solving problems, okay? So these are 3 perfect examples I want to use. Like I said, when you're doing stuff, when you're simplifying things, you have to use everything you learned from the past. Basically, in this example, they want you to reduce. Okay, reduce to lowest term, okay? Reduce to lowest terms. Alright? These 3 examples, that's what they want you to do. Reduce to lowest term. We're going to do a lot of problems like that. But so remember what I said. What is the first step? You factor. 1, factor numerator and denominator. You factor them out. And then second step, what do? You divide with the common factor. Remember? You divide out. You can say divide out common factors, okay? You can say it like that. Divide out common factors. So first you factor and then you divide out. So let's do it. Look at number 1. You see number 1 there. Look at it carefully. Look at it. Look at the numerator. Look at the denominator. If you look at the numerator, you see 3 can go into 12. So basically, you can write the numerator like this: 3x minus 4. You see that, right? Because you can say 3 times x is 3x. 3 times 4, 3 times negative 4 is negative 12. So that's the numerator. Look, do the same thing in the denominator. You try to factor stuff out. So what do? Look at 5 and 20. You say 5, you pull 5 out, x minus 4. You see it, right? So you're gonna be doing stuff like this all the time. Just you need to be comfortable doing it. You gotta be able to pull something out. Once you pull it out, look. You see the common factor there? Look at the common factor there. Once you pull the thing out, see? That and that are common factor. You can cancel them out. Remember what they call cancel culture. That's what we're doing here. We'll cancel stuff that cancels out. We'll cancel them out and they disappear. Okay? So once you do that, what do you got? Then you got 3 over 5. That's the answer. That's the lowest term you can get. That is in lowest terms now. You cannot, there's nothing else to divide out. Now we'll move to the second example. Look at that. You do the same thing. You eyeball the numerator, you eyeball the denominator. Look at the numerator carefully. You can write it like this. See, x is in one term. Because you see, the numerator is a polynomial. It's actually a binomial. Binomial with 2 terms. This is the first term and this is the second term. The first term has x squared. The second term doesn't have x. So you can't deal with x. You gotta leave x alone and worry about the number. Notice that 2 can come out. 2x squared minus, let me see, you can say 4. Yeah? 2 times 4 is 8, you see? So you just find out what you can pull out. That's all. Once you pull it out, then you can cancel things out. Look at that. Look at the denominator. You can't mess with x, but you can mess with the numbers. So you pull out 2x plus 2, because 2 times 2 is 4. See that, right? Basically, you're going to be doing it. We're doing a lot of this. Pulling stuff out. Once you pull stuff out, then things will cancel out. But you see, we still got I can see something. I don't know if you see it. Look at this one. We can factor this too. We can factor this. I'm talking about the whole thing here. Notice that it's 2 squares, because you can write it like this. X squared minus 2 squared. You see that? It becomes x. We did this in the past. Plus 2 times x minus 2. You see that? If you multiply them out, you get that. So you can then write this like this. I gotta use the black pen. You can write it as 2x plus 2 times x minus 2. Okay, so then you can say 2x plus 2. So the trick is, see, when we ended up here, look at that. We saw that. And then you start looking up here. Say, well, this one can be written like that. There's part of this that is in there. So if that helps you to visualize, that's good. So then what happens? This will cancel that. We'll cancel the cancel culture. We'll cancel that. Then we'll get x minus 2. That's the answer. That's the reduced term. So in reduced terms now. You see that, right? Please make sure you understand what is going on. You have to be able to look carefully, see what you can cancel out, what you can factor out. Okay, I've chosen this on purpose. That way you can see it. I chose it in what do you call that? In order of complexity. See, that one is easy. Number 1 is easy. That one is a little bit confusing. Now this one is really confusing. You see the example number 3. See that? Now the numerator and the denominator, they have to be factored out separately. So let me write it out. Numerator. That's what you have to do. Numerator. You don't have to write it out, but I'm just trying to show you. So let's do with numerator. What is numerator there? Is x squared plus 2x minus 8. Now we have to factor that. Factor it any way you want. I showed you 3 methods you can use to factor stuff. 1 is to just factor it. 2 is to use what is that? You use completing the square. 3rd, you can use the the formula, the binomial formula, because that's a binomial right there. You can use a binomial, the binomial formula we developed. You remember? So the first method is to factor it using this. You draw a cross like this. That's the one I prefer. Choose whatever you want. So the idea here is you look at the third term. You find the factors of that will, when you multiply them, they give you -8. But when you add them, they give you 2x. That's all. So look at 8 carefully. What two numbers can multiply together to give you -8? Well, we can have 2 minus 2 and plus 4. If you multiply them, you get -8, right? Will it work? Yes, it will work, because when you add them, you get 2 of their 2x. Let me show you. So you take this one, you split it apart. If you didn't watch the video where I talked about factoring, that was the last video. Go watch it. No, last video was application. It was a video before the last video where I talk about factoring. Okay, so this thing, x squared, can be written like this. X, you see that? You split it into 2, into the factors. See, x times x will give you x squared. Okay, and then 8. I said these two factors of 8 will work. So you put -2 here, +4 here, and then you make sure it will work. You multiply like this, and you multiply like that. You see that? So you say x times -2, you get -2x. Okay? You say x times 4, you get 4x, right? You add them, what do you get? Well, let's not do it that way. Let's do it this way. If you add them, we're just trying to see if we're doing it right. You add them, what do you get? You get 2x. That's what we're looking for here. So that means what we chose will work, okay? Again, go watch the video. I have extensive video, extensive examples on this. Then say the factors are this. So the numerator can be expressed as x minus 2 and x plus 4. You see that, right? So that's the numerator now, okay? That can be broken down like that, okay? Now let's do the denominator. So I chose these examples that way you can see. What is the denominator? 2x squared. What is that? Oh, sorry. 2x squared minus x minus 6. Now you do the same thing. We use the same method, okay? Now you say, what are the factors of -6? That way, when you multiply them together, you get -6, -6. When you add them, you get -1x, because that's 1 here, but we don't usually write it, -1x. Now think about it. Now don't forget that we have a problem here, because this is 2x, and the x will give you 2x squared. Okay, so you write it out like that. So let's try. I know that 2 and 3, if you multiply them, you get 6. But which one do we choose negative? Which one? We have to choose one of them negative. That way we can get -6. Alright? It depends on where you place them. Okay, so if you eyeball it, we're looking for that. If you eyeball it, let me see. Yeah, if you put 2 here, you put 3 here. Because when you multiply that, you get 4, right? When you multiply that, you get 3. So we want -1x. So actually, want that negative. You see that, right? Because let me show you. If you multiply it like that, you get 3x. You multiply like this, okay? You get -4x. You see that, right? So when you add them, what do you get? You get -1x. That's what we're looking for. So that thing will work. So we'll clean this out. Please, I hope you understand. If you don't understand, just go. There's a video I made on this. So our factors are this. Now our factors are this. Our factors are 2x plus 3 times x minus 2. These are for the denominator. So basically, you take what you found. You found that. So the numerator is x minus 2, x plus 4 over, what is that? We found this one, okay? For denominator, 2x. I'm sorry. I'm going too fast, man. Sorry about that. 2x plus 3 times x minus 2. See that, right? Look at it carefully. Look. This cancels that. So it's cancel culture. You cancel that thing out, and then after you do that, you have x minus plus 4 over 2x plus 3 left. So that's the reduced time. I don't think there's anything else we can reduce. That's the reduced time we're looking for there, right? There's nothing else we can do. So it's reduced. So these 3 examples, try to understand them, because you're going to see a lot of that as we'll solve a bunch of problems, okay? So let's go solve a bunch of problems. Okay, so all these problems we're solving now, we're going to solve a bunch of it. So all of them, you reduce them to the lowest terms. That's all. So I say reduce the following to the lowest terms, okay? See the number 1 there. What do you do? Look at it carefully. Notice what is going on there. You see what is going on there, right? So notice you can write this as this. Write it like this. It's 2 times 2, all right, times x minus 2 over, what is that? 2 times 5, yeah, times, what is that? X minus 2, right? Notice what can cancel out, man. So you start with, we're engaging in cancel culture. You cancel that, cancel that. You cancel that, cancel that. What you have left is 2 over 5. You see that, right? That's a reduced term right there. So we'll move on to the next one. Look at that one. Look at it carefully. What can you cancel out, or what can you factor? First, you start by factoring. We just factored. You see what we did here? We factored 2. I'm sorry. We factored 4, we factored 10, okay? There's nothing to factor on this thing. It's already factored for us. So you start by asking, what can you factor out? That's the first step. Find out what you can factor out. You factor it out, and then after you factor, then you start canceling stuff out. So you factor, and then you cancel out, okay? Alright, so let's deal with this one. Look at it carefully. You can say, let me see, you can do 3 times 5, right? And then that's nothing to do there. And then you can do, what is that? 3 times 3, right? Will give you 9. There's really nothing to do with the variable. You leave the variable alone. If it's already factored, you don't have to worry about factoring. So this cancels that, and that cancels that. So what do you get? You get 5 over 3. That's it. It's reduced now. Once it's reduced, you leave it alone and move on to the next one. Look at that one. See, these are all variables. No constant anywhere there. Well, they have constant inside the brackets, but I'm talking about the brackets themselves. They're all variables. Okay, so we can factor something. Notice this: x plus 1, x minus 1, okay? And notice we can factor the 1 on the bottom. It's like this: x plus 1 times x plus 1. We've done this many times in the past. You see that, right? Because that when you have that exponent there, it means you multiply that twice. That's all. So look at it carefully. This one will cancel that. And then what you have x minus 1 over x plus 1. I don't think there's anything else for us to cancel. You see that, right? So we'll leave it like that. You're done with it. You move on to the next one. Look at that. The same thing as what we did before. So you have x plus 5 and the x minus 3, okay? And then it's x plus 5 times x plus 5. So you see it, right? This can cancel that. And then you got x minus 3 over x plus 5. And then you're done with that, you move on, okay? Once you're done, move on. Okay, what do we do with this one? Now we'll have to look at it carefully. You always have to have sharp eyes. You can pull things out. Look at 7 and 14 on top, on numerator. Look at the denominator, 5 and 10. So you can pull things out of there. Pull 7 out of there, you get x plus, plus 2. Because 7 times 2 is 14, okay? And then here you pull 5 out. Pull 5 out of there, 5 times 2. You see that, right? So you gotta have sharp eyes to see what you can pull out. So once you've done that, look. You see what's going on? You cancel that out, you get 7 over 5. You see it, right? So you always have to have sharp eyes. That way you can see what is going on. Alright, here is number 6. We're continuing. Reduce to lowest terms, okay? So see number 6 there? You eyeball it, look at it carefully. What can you pull out? Especially when you have in the numerator, if you have a variable in one term, and then in the denominator, if you have a variable in one term, see, this is a variable. You know what is this is a variable. It's only in one term, okay? So this is a binomial with the variable in one term. The second term has no variable. So the idea is to pull something out of it. You know, that's the only way you factor, pull something out of it. Okay, so we'll go. What is that? We'll pull. We can pull out 8. 8 times 2 is 16. So 2x plus 1. You see that, right? Pull out here. You pull out 7. You pull out 7 out of there. What do you get? 2x plus plus 1. You see? So when it's laid out like that, pull something out. You pull it out and then you go. You see? So this can cancel that. So you get 8 over 7. You see it? So you should be able to see that, you see. Start pulling stuff out. Pulling stuff out of there. You know. You're pulling stuff out of there. That way, that's the best strategy, okay? Alright, so let's move on to the next one. What is the next one? Look at it carefully. Eyeball it. Eyeball it and see what you can, how you handle that. Again, you see, the variable is in one term, so we'll have to pull stuff out. So right there, you can say 6 can go into 18. Yes. 6x, alright, minus 3. 6 times 3 is 18, yeah? And then you pull out 7. 7 can go into 21 3 times. You see that? It's almost like if you can get the first one, you know the second one is gonna come out. That's how they design these problems, you see. Some people take time and design and construct these problems, you see. So that can cancel that. You get 6 over 7. Don't think that people don't think that these problems fall from sky. No, people sit down. People are get paid to sit down and design the problems, okay? Alright, so look at the next one. The same thing. We're going to pull something from the sky, you know, see? So pull out 5 from the numerator. You have x plus 4, you see? And then you pull out stuff there from the denominator, x plus 4. You see that, right? Yeah, you can find out how they design the problem. Alright, so this cancels that. You got 5 over 3, okay? That's it. And we'll move on to the next one. Okay, over here, we'll have to use what we learned. There's a video. I covered this. These are special factoring techniques you use. When you have a difference of 2 squares, you see, it goes like that. It goes like that, x plus y and the x minus y. You know, remember we talked about that in one of the videos. And then x plus y, see? So this one cancels that. You get x minus y is the answer. So if you don't understand it, go to one of my videos. I talked about that. You know, that's actually like, it's like a formula. It's like a formula that, you know, you pull stuff out. You just have to memorize it. That's all. Memorize the formula and then you're good to go. So let's look at the next one. Look at that. Look at the next one, man. It's almost the same thing we did on number 9. It's a special formula. The numerator, you write it like the, I'm sorry, you factor it. That's the way you factor that. Like that. X minus y. Again, go watch my previous videos, man. So this cancel that. You get x plus y. You see that, right? That's the answer there. There's nothing else you can do. You've done the work there. Okay, so let's keep going. Okay, here are more examples here. We'll keep going. I have a bunch of examples, then we can move to another topic, okay? I think I made it too large. Anyway, you see the number 11 there? See the same thing. You start pulling stuff out. Well, look at the numerator. It has the both. It's a binomial, but the two terms of the binomial has x, has a variable, but it doesn't matter. So what you can do, pull stuff out like this. 3x, okay? If you have it like that, you can pull 3x. That's all that means. Minus 1, you see? Put 3x out. And then in the denominator, is you pull 5 out. X minus 1. You see that, right? See how they designed the problem. So you got 5x. See? I'm sorry, not 5x, 3x. 3x over 5. It's nothing you can do. You're done there, man. It's nothing else to do. Okay, so you go to the next one. Look at that. The same thing, similar to what we did above. You pull, let me see, pull 6x out. You get x there. You get 1 here. Okay. Then you get, let me see, 5. Pull 5 out. X minus 1. You see? That's how they designed it. You get 6x over 5. Okay. All right. Move on to the next one. Look at that. Look at that. This is a little bit more involved. 9x 6. Yeah, you can pull stuff out. Pull stuff out. Start pulling stuff one by one until you start seeing a pattern, right? You pull stuff out, then you can see other stuff to pull out. After seeing it there. You pull one thing out, then you see more stuff, okay? Alright. So we'll pull, let me see. Actually, no. Let me see. We can pull that out. Okay, I see what they're doing. Notice this. This is like a 9. It's like 3x squared. You see that? Minus 2y all squared. You see it? You see how I did it? That's what you have to do, man. And then this one here, you can see, let me see. You can see 3, pull 3 out, x plus 2y. You see it? Okay, look at the top. You remember this is difference of squares. So you can write that. You can write the numerator as 3x plus 2y, because it's difference of square. I have a video on that, man. And then 3x minus 2y. You can write it like that. Okay. And then you have, let me see. Yeah, you can write it like that. Of course. So it's a 3x minus plus 2y. You see that, right? And let me see. That's a little messy, man. Now, what do we do? When we have it like that, what do we do? Notice something. Let me see. It's a little confusing, man. Okay, I think I noticed I made a mistake. Listen. You see, you gotta watch it, because I looked at it. Things are not coming out right. Notice that I made a mistake. They're supposed to be 3. You pulling 3 out, you have to leave 3 in there. You see it? So I made a mistake there. I was saying nothing is matching. Because you see, like I said, the way they designed this problem, they designed to match. So it's 3x plus, you see that, right? So once you put it like that, then you can see This cancel that. Alright? So what do you got? You got 3x minus 2y over 3. I don't know if you can see that. You see that? So yeah, when you come like that, if you things don't start canceling, that, you know, check what you did before. Maybe you made a mistake. Because I made a mistake here. 3 times 3 is 9. Then 9x. 3 times 2 is 6y. But you see, when I put it, I forgot to leave 3 inside there. So we're done with that one. We'll go to the next one. I think it's the same. Notice this one. We can write it like this. Notice something. I think it's the same idea there. You can write it as, you know what, let me do it here. Let me go from here. That way I don't confuse you. We'll go like that. Notice that you can write it as 4x squared, like the difference of square, 3y squared over, you pull something. What do you pull out up there? You pull out 3. Because you have to consider that 9 there. Pull out 3, you have 4x minus 3y. See, this is where I made mistake before. You gotta pull it out like that. Now, the numerator has difference of squares. So you have 4x plus 3y. That's what you do with difference of square. And then 4x minus 3y. See that, right? Again, I have video on that. Go search the video. And then you have 4x minus 3y. So you see how they designed the problem. See, that will cancel that. And then what do you have? You have 4x plus 3y over 3. Do you see it? You see it, right? If you think about it carefully, that's what they want us to do. It's nothing else you can do. You can't pull anything out anymore. It's done. You know. So the next one, look at the next one. The next one is let me cordon that off. Let's say equals to, let me see. Okay, look at the numerator. Numerator is okay, so you leave it minus x minus 6. Denominator is a difference of square. You can write it like this, negative 3, what is that, 6. You see that 6 times 6 is 36. So that becomes x negative 6, and then x, let me see, x minus 6, well, you can say x plus 6 and x minus 6. You see it, right? This is difference of square. That's how you summarize it right there. So this will cancel that, and then you get 1 over x plus 6. You see it? There's nothing else you can do. That's it right there, man. Okay, look at number 16. You see, the numerator is like difference of square, and the denominator will have to factor. So we'll factor both of them. Let's start with the numerator. You can write it as x squared minus 3 squared, okay? And then x squared minus 6x plus 9. Okay, notice that you can write that thing as x, alright, plus 3, and then x minus 3. Notice that, right? Okay. Now notice the denominator. We gotta use our method, man. So let me start over here. The denominator, look at that. Put x here. This x. Okay, x times x is x. Look at 9. What are the factors of 9? That way, when you multiply them, they give you 9. They give you positive 9. When you add them, they give you negative 3. Notice this one is very simple. Try this. 3 times 3. 3 times 3 will give you 9. 3 plus 3 is negative. So basically, yes, negative, negative. Notice that. Negative 3 times negative 3 will give you positive 9. Negative 3 plus negative 3 will give you negative 6. You see there, right? So that's our goal. So we're done with that. So that will, the numerator, I mean the denominator will be x negative 3 and the x negative 3, like that. You notice, right? So we'll put it here, x negative 3 and the x negative 3. You see it? Notice that this cancels that. So you get x plus 3 over x negative 3. There's nothing else we can do. If you see anything else we can do, tell me. We're done with that one, so we'll move down. Look at that one. They are still similar, the same thing. You have difference of square on top. So I'm going to start abbreviating stuff, That way I don't have to write too much. See, this is a difference of this and 4 right there. Okay? And then when we factor it, you see. So let's do it this way. Let's factor the denominator. If you factor, you get x here, x times s will give you that. Now 16. What factors of 16? When you multiply them, you get positive 16. When you add them, you get negative 8. Try the same thing. Try 4. Try negative 4 and negative 4. You multiply them, you get positive 16. You add them, you get negative 8. You see it, right? So the factors are there. The factors, I'm going to write it up here, okay? Well, let's write it up here. It doesn't matter. X negative 4. If you on time crunch, you don't want to waste time writing stuff out, your teacher will see it. And then that's the same thing as x plus 4 and the x minus 4. The one on top, the numerator, you see that, right? You see the numerator breaks down like that. X minus 4 and x minus 4 again. Notice that this cancels that. So it's like the other one with the net. It's like number 16. X plus 4 over x minus 4. That's all. That's the lowest time we can go. It's nothing else. That's nothing else we can do. No matter what you do, you can't reduce it anymore. That's it. Okay, so we'll go to the next one. Let's go to number 18. What is that? Okay. All right. This one is a little bit touchy. Let's eyeball it, man. All right. If you look at it carefully, notice you can pull on top. You can pull 13 out, and you can also pull x squared out. On the bottom, notice you can pull 7 out, you can pull x out. So let's try that. So this is 13x. Let me see. 13x squared. You can pull it out. It becomes, what is that, 1 here? All right. 1 minus, because 13 times 3 is 39. So you put 3 here, and then you put x here. You notice what I'm doing. You see it? And then the bottom you put 7x. I'm sorry, I'm going too fast, man. I gotta slow down. What the hell? This stuff is so big. Let me see. Yeah, 7x. You pull it out. You get 1 here minus. See, 7 times 3 is 21. So 3 here, 3x here. You see how they make the problem? This will cancel that out. That will cancel that out. So you get 13x over 7. You see that? You see that, right? Because x can divide x squared, and you get that. That's all. Anyway, let's move on to the next one. Once you finish, move on. Look at that one. You see what is going on there? The same thing as the previous one. You start pulling stuff out. This thing here, you can pull, let me see. You can pull 15. You can pull 15 out. Okay, 15. Yeah, 15x to raised to the power 3. You can pull it out. Right, you get 2. What is that? You get 2 here, right? And then the next, that one is you pull 15 out, so you get 1 there. And then x, it will be 2, because x cubed times x squared, it give you x raised to the power 5, okay? You put that out like that, and then look at that one. Look at it carefully. You can put, you can put 11 out, because if you put 11 out, also pull x squared out, so you get 1 here. Is that it? Yeah, you get 1 there. And then, what is the, yeah, No. You get one, the other one. Let me see. You know, you get 2 here, 2. You get 2 here, right? You get 2 here, and then you get x raised to power 2 here. Did I do it right? Yes. Yes, I did it right. Because you always want to pay attention to this here. Pay attention. Something down there will cancel either with it, you know. So that's how they designed the problem. Notice that this canceled that. And notice that x squared. Remember I told you, let me write it the way you can write it out. Look at that, 15x cubed over 11x raised to power 2. Notice that I told you about the exponent. Remember what I told you about the exponent? So this is 15 over 11, alright? And then x3 negative 2, like that. I don't know if you can see that. If you don't see it, don't worry about it. Because 2, that x will cancel. This will cancel something there, see? 11 over x raised to power 1. We usually don't write it. We leave it like that. Did you see what I did? If you didn't see what I did, let me make sure you see it right here. Let me write it. This is 2 here. So I try to cancel in. You see it? If you don't see it, don't worry about it, man. Now you can look at this or you can do it there. Because here, sometimes I get messy. Let me show you. If x squared cancel x cubed, then you get x left, right? Okay, that's what I just did there. Now let's move on. Alright, let's go to the next one. Let me see, that's 15x. Okay, let's go to the next one. What are we doing there? We'll see. It's almost the same thing. We'll have to factor the numerator, and then we'll have to factor the kind of the denominator is already, I don't know, you can't do anything there. So the numerator will go like this. You gotta be very careful. It's 5x somewhere, and the x, you multiply, you get that. Okay, now look at the factor. What are the factors of 6? I can see, let me see. We can see 6 and 1. If you do 6 and 1, right, let me see. 6 and 1, if you put 6, no, 6 and 1. Suppose you put 6 here, and you put 1 here. If you multiply them, we're looking for negative that, right? Yeah, I think it will work. Let me see. What is 6 plus 5? 6 plus 5 is actually 11. So that won't work. 11 plus this, that will be 12. Yeah, that won't work. So we need, let's change that. It won't work. You always eyeball stuff. Suppose we do 2 and 3. Okay? Okay, so let's say 3 times 15. 3 times 5 will give you 15. 15 minus 2 will give you what? It will give you 13, right? So that's it. So we'll put this negative. You see what I just did? Negative 3 times 2 will give you negative 6 right here. Negative 6 right here. If you multiply them, you get negative 6. But if you add them, you not go quite add them there. You gotta do it from here. Watch this. You gotta do the multiply like that. What is 5 times 5x times negative 3? You get negative 15. 15x, right? And then you gotta do this one. The problem is when you have that, so that's how you have to do it here. You can't do it. You can't do it between these and that. You gotta do it between 4 of them, okay? 2 times x, you get 2x, okay? Now if you add those, what do you get? You get negative 13x. That's what we're looking for right here. Right here. You see that, right? So let me make it clean it up. You don't want all that messy stuff. Clean it up. We got it. So our factor term are there, right there. So we say the numerator will be 5x plus 2 times x minus 3, okay, over 5x plus 2. See, that's what we have here, right there. Okay, look at that. You see, look at that magic. That cancels that. And then what you have left is x minus 3. You see, right? No, nobody can, you can't change anything there. You reduce time. We'll move on to the next one. Look at that. That's the same. That's like the other one. That's like number 20 we just did. You can't really do anything in the denominator. It's set. You gotta factor this one. So let's factor that. We'll factor the numerator using our method. I like to use this method. So now we'll have the same problem because, let me see, yeah, we'll have 7x and the x. You multiply them, you get that. Now we'll have to find the factor of this, and then we'll have to take that 7x into account. Let's say 4 times 5, right, is 20. Suppose we put, let me see, 4 times 5 is 20. If we put 5 here, we'll put 4 here. I don't know if it will work. What is 4 times 7? Okay, that's 28. So you see, it won't work because if you multiply this, you get that, you multiply that. Even if I make any of them negative, it won't work, right? Because we're looking for 31. So let's switch it. Let's put, we'll put 4 here. Bear with me. We'll put 4 here, and we'll put 5 here, okay? 5 here. We'll say, you see what I'm doing, right? You gotta, eyeball it, try it until you get it right. Okay, 5 times 7 is 35. Let me clean it. I hope you see what I'm doing. 5 times 7 is 35, okay? 35x. 4 times x is 4x, okay? Okay, if you add them, you get 31. But which one are you gonna make negative? So you have to make this one negative, okay? So that means we'll make that negative. I hope you see what I'm doing. Let me clean it up. I'll show you. You gotta make that negative 5, because negative 5 times 4, you get negative 20. Negative 20 right here, okay? And then if you multiply this way, you get 4x. You multiply this way, you get negative 35. You add this negative 35 and positive 4x, where it's negative 35x. You add that, what do you get? You get negative 31x, and that's right there. You see it, right? So our factors are that. So we'll say, I made a mess here, man. Sorry. Let me clean it up, that way you can see what I'm doing. Then we'll say that problem is the same thing as 7x plus 4. I'm reading it from here. 7x plus 4 times, right here, x minus 5, okay? All divided by 7x plus 4. I'm copying this over. Notice that the problem, so you see how it resolves? If you do that, you get x negative 5. See? That's the solution. There's nothing else anybody can do. So we did that right. You see, right? X minus 5. That's the solution. Nobody can change it. So we are done with that. Okay, let's move on to another topic of this video, okay? The next topic is multiplying and dividing rational expression, sorry. After this, we'll do adding and subtracting rational expressions, okay? After that, I will explain to you, the process of simplification can involve all of them. It can involve multiplying and dividing. It can involve adding and subtracting. So, when you have a complex rational expression, all these operations, multiplying, dividing, adding, subtracting, will be involved, okay? But we'll take it one at a time. Let's do multiplying and dividing rational expressions. We'll take care of that right now. So what does that mean? Okay, here we go. To multiply, I'm gonna write it out, that way you get it, okay? Just follow me carefully. to multiply two, I say two rational expressions, okay? I just want to make you sure you understand it. To multiply two rational expressions, okay? You multiply their numerator. You multiply their numerators and you multiply their denominators, okay? You know, this seems very simple, but I have to write it that way. Okay, but I will show you how to go about doing it. To multiply two rational expressions, you multiply their numerators and then you multiply their denominators, okay? And then you then proceed to simplify. But let me show you, let me write it with the abstraction. Let's say you have this here is a rational expression, okay? That's the first one. And you have this one, another rational expression. Okay, you have both of them right there. To multiply them, you go like this: A over B times C over D, okay? You multiply them. What did I say up there? You multiply the numerator and you multiply the denominator. That's all. You say A times C over B times D. That's it. You get that, right? That's all we said there, man. I didn't say more than that. Different books will tell you different things, but that's what is going on. I'll give you an example. Let me give you an example. Suppose you have 3 over, just like a regular fraction using numbers. You have this, 3 over 2 times 3 over 8. What do? You say 9, you multiply 3 and 3, you get 9, 8 and 2, you get 16. So once you do that, what do? If you want, you can simplify. There's something to simplify, you simplify. But in this case, I don't see what you can simplify. You leave it like that. Okay, supposing you have this 8 over 9 times 3 over 10, okay? What do? You multiply the numerators, you multiply the denominators. That's what I said up there. So 8 times 3 is 24. 9 times 10 is 90. See that, right? So now that you have it like this, you can simplify. Okay, 6 goes into 24, you get 4, okay? And then what of 90? I think 6 goes into 90, right? 6 goes into 90, you get 15. You see that, right? So basically what I did is come over here. Yeah, I can go from, I say, no, from here. We'll go from here, forget about that one here. We'll say that, we'll write it like, as let me see, 6. We'll say 6 times 4 over 6 times 15. You see, that's what I did. And then this cancel out. And then you get 4 over 15. You see that, right? That's what we just did. You remember that thing I told you? If you got sorry, I told you earlier, if you got P and you got Q and you multiply it by K, right? See, it's something as P over Q. That's what we just did here, okay? So these are examples I want to give you. So what we're going to do, make sure you understand my definition, right? Let's define what you do when you divide, because they go together. All right? Just give me a minute. Okay. Here is how you do division. To divide a rational expression with another rational expression, you multiply by its reciprocal. I wanted to make it as simple as possible. I don't want to make it complicated. Different books will say different things, okay? Let me explain to you what I'm saying. You got rational expression A over B, okay? And you want to divide it with another rational expression, C over D. So what I'm saying there is you multiply with the reciprocal of this. You understand it? So you turn that into, you do it like this, A over B, and you multiply by D over C, which is the reciprocal of that. You see that, right? That's all. I want to keep it simple. To divide a rational expression with another rational expression, right? You multiply by its reciprocal. I'm being the reciprocal of the second one. The divisor. This is called the divisor. This is called the dividend. So you can reward that. So to divide a rational expression with another rational expression, you can say you multiply by the reciprocal of the dividend. If that makes you feel happy, fine. But I want it simple. Very, very simple like that, okay? I'll give you an example. We're going to solve a bunch of problems, but let me give you an example. Suppose you have 5 over 8 divided by 2 over 9. My definition up there said just do 5 over 8 times 9 over 2. That's all. And when you do that, what do you do? What do you get? So you can divide things, well, you can multiply things out. It becomes, let me see, what did I do? Yeah, this is what you do. You swap it around like that, right? So then you can use the whatever you want to do. You can then multiply it out, well, however you want. You can then say 45 over 6. What is that? 16. You see that, right? 45 over 16. All right. So what we're gonna do? That's all I want to tell you. Don't forget what I told you about the exponents. That's where when you divide in it, the properties of exponents they become important. Especially that one I showed you earlier today. Okay. So let's solve some. We'll solve some problems. That way, it will help you to understand the two operations I just defined. Okay. Okay. We're gonna do some problems in multiplication, and then after this, we'll do some problems in division. Then after that, we'll do a mixture. Okay. So you say multiply this out. You see that, right? We're just multiplying it out. So the strategy here is. It's just like the strategy we use in the fraction, Well, the first one is fraction, but I started with fraction. That way you can see that they are fraction, but actually they are polynomials. That way you see how you can break things apart. If you want, you can multiply 4 times 15 and then 9 over 9 times 16, but that you're making it too complicated there. So what you do, you break things up, break the numerator apart into their component factors, and you break the denominator into their component factors, okay? And then you start seeing things cancel out. So you multiply that, and look at that, you get 2 times 2, all right? Times, what is that, 3 times 5. I'm sorry, let's not use too many symbols. 2 times 5, okay? And then you can say 3 times 3 and 4 times 4. You see that, right? So you can break it apart more. Look at this. This go into that. We know that those two are 4. One of them go out. So you can have, let's see, you have 5 over 3 times 4, which is 5 over 12. You see that, right? So you just do it the way it's best for you. You just break it apart. It's better to break it apart. That way you can start seeing what can be cancelled out. All right, let's move on to the next one. Look at that. This is 2 times, I'm sorry. We just want to use the same 2 times 5 times 3, okay? And then you get, what is that, 7 times 3 times 5. You see that, right? So you see things will start canceling out. You get 2 over 7. You see? So that's the idea. Break things apart. Once you break it apart, things will start canceling out. So make sure you understand this. That's where when you get to right now you can see things clearly, but when you get to when variables are involved, you do the same thing. Okay, that's 3 times 5 times x times 7. You see? 2 times 7 times 5 times x. You see that, right? This cross out, that cross out, 5 cross out. You see that? You get 3x left, 3x over 2. You see it? So this is how you cross things out. Just make sure you don't leave anything behind. You just keep crossing things out and keep going. Things will come and you will start seeing things you can cancel out. So let's do this one. Okay, that one is, let me see, is 3 times 7. All right, times what? Times, okay, this is, see, when you see that, let me show you. It's up to you how you do it, right? Let me leave the x for a minute. We said 3 times 3, okay, times x. See, look at that x and that x. I can say 6 by, no, it depends, I don't care how you do it. Like that, okay. See, and then you can do 3 times let me see, 2 times 3, like that, and then times 7. You see that 7 cross 7, 3 cross 3, 3 cross another 3. What do you have? That one simplifies. What do you have? You have 3x. That one simplifies to 2. X raised to the power 2 over 2 right there. I don't know if you see what I just did, man. Did you see what I just did? That's all you can do. Anyway, it's easier for you because remember I told you the exponents. I told you when you have a raised to the power m and then a raised to the power n, it becomes a raised to the power m minus n. That's what I just used over here. That's what I used over here. So whatever works, whatever you learn from before, you apply it and knock things out. That's all. Okay, ambulance was pausing, so I had to pause this. Okay, but anyway, let's go to the next one. What is that? Start expanding things, and that way they can cross out. 2 times, what is that? 2 times, you can say 2 times 8, but then 8, 2 times 4, all right, and then of course you see that x. Let's see, if you want you can multiply it out. It's up to you, man. But let me leave the x for now. I said 3 times 5. Notice those two x. X times x. Don't forget another rule of exponent. Okay, when you have x raised to the power m times x raised to the power n, it becomes x raised to the power m plus n. You remember that? Okay, so let's apply it here. Let's apply that here. We'll have times x. See, x here, x here. It becomes x 4 plus 5, like that. You see that, right? And then down there we'll get 3 times 6, and then 6 is 2 times 3, okay, and then that the x in bottom, the x at the bottom will be x 5 plus 2. You see it, right? So let's you do whatever that works for you. Right there, that cross out, that cross out. You see that, right? So we'll simplify the rest of it. We'll have 2, let me see, hang on a minute, 2 times 4 times, that's 2 times 4, that's 8, 8 times, hang on a minute, we'll leave it like that, 2 times 4 times 5, and then x raised to power, what is that? 9 over 3x raised to power, what is that? Raised to power 7. Notice that that is something as 2, 4, 5 x 9 subtract from 7, 9 minus 7 all over 3. You see that, right? So I don't read this one. Is a little it's a little, okay. 5 times 2 is 10. 10 times 4 is 40. 40 over 3, and then x raised to power, what is that? 2. I don't know if I did it right. I think I did it right, man. See that? You see that? So you follow it wherever it goes, wherever it leads you to, you go over there. So I think we did it right. So you can check it, see if we did it right. Now look at this one here. Look at this, is something. You expand stuff, cancel stuff out. Use whatever you know that works for you. You say 2, let me see, 2 times 6, which is 2 times 3, okay? And then you combine the x. You combine those x, what do you get? Is x 11 times 2 times 3. You see that, right? Do whatever is best for you. 2 times x. You combine the x. You combine the x in denominator. You have 5. Okay. Times, what is that? 2 divided 28. You get 118. That's just give me a minute. Let me simplify that. This is what I got right there. Okay, so you start canceling things out. This cancel that. That cancel that. That will cancel that. So basically you get, here's what you get. You get 9 over 7 x 11 minus 5. So you get 9 over 7 x raised to power, you remove 5. If you remove 5, what you get? You get 6, right? 6, yeah. That's what I got. Yeah, so you do it the way you want, but I think it's fun doing it this way, man. I'm telling you, I'm having fun, man. So, but you gotta know how to manipulate all that stuff, fractions, exponent. Go watch my video in exponent. You try to learn it. You stop the video, you solve the problem on your own, see if you get the way I solved it, because I'm using all that here. This one, let's expand it. This one will have to kind of, well, actually you don't have to expand, because I see if you expand it, you make it too complicated. So leave it like that. This is how I'm going to expand. Well, actually I take it back. Expand it like this. 2, you leave c plus d, leave it in the bracket, and then you expand that 2. Let me see, 2 times 3, what is that, 18? 2 times 9, yeah, it's 18, 3, okay? Okay, then you do the same thing, 3 times 2 times 3, okay, then you expand that thing, c plus d, and then c, I'm sorry, I'm going too fast. That's C, another C. Spending the thing in the bracket, another D right here. You see it, right? So you cancel that, this cancel that, this cancel that, that cancel that. You see that? Things start canceling. Now this is a cancel culture we're doing here. You have 2 over C plus D. That's it. You can't do any more than that. Nothing else can cancel, you see? So this is a kind of fun, but you gotta look through the variables and try to manipulate it, that way it comes up to what you want. Let's find some more problems, okay? Okay, look at number 8 here. Okay, so we will proceed the same way. Let me see, let me see. Look at the numerator. That term in the numerator is in the denominator, and 10 is in the bracket. So there's really not much. Let me see. Okay, let's do it this way. 2 times 2 times y minus 2 times 3 times x, right? Okay, this equals, over divided by x times 2 times 3 times y minus 2 times y minus 2. You see it, right? So that's y right there. So we divide, that thing will cancel out, this will cancel out, that will cancel out, this will cancel out. See, things start canceling out. So what is left there is, let me see, 2, nothing is left except 2 on top. It's y negative 2. You see that, right? That's all. We'll move on to the next one. I bought that. I think it's almost the same thing. We'll say x minus y, x minus y times, what is that, 2 times 12, and then you go 2 times 6, and then 2 times 3. See that? You just break it down like that, man. Any way you can. You say 2 times 3 times x minus y. See? So this will go with that, this will go with that, this will go with that. See? We'll break it apart. There's nothing left in the denominator. So the whole thing will be, let me see, what is that? 4x minus y. I don't see anything we can do. See? We broke it apart. There's nothing left. Okay, so we'll do the same thing here. Let me see. You just break things apart and then cancel them out. A plus b times a plus b times, what is that? 2 times 15 is 30, okay, times 3 times 5, okay. You see what I did, right? 30 times 15, break it apart like that. You just find the factors, man. Start breaking it apart. 2a, plus b. This will cancel this. This cancels that. This cancels that. See, what do you get? A, well, 3a plus b. That's it. That's it, man. 3a, 3 times that thing in the bracket. That's it. So you keep going. What is that? Break it apart. X minus 4. Let's put it in bracket times 2 times 2 times x. Okay. All right. You go 2 times 2 times 2 times x minus 4. So this cancel that, this, that. You see it, right? So basically what is left is x squared over 2. I don't see nothing else we can do. Can't do anything, man. All right. And then we keep going. What is that? See, we'll break it apart, then we'll build it back. That's all we're doing, man. X plus 9. Let me see. Because it's multiplying, so you can't separate that yet. Like that. 3 times x. Okay. You go 3. 2 times, what is that? No, 3. Let's do 3 times 4. 2 times 2. Okay. And then x plus 9 inside bracket. You see, goes with that. This go with that. So basically what you have left is x squared over 4. I don't think we could do anything. There's nothing else we can do. Can't do anything, man. We're done with that. We keep moving on. What is that? Break things apart. 3 times x plus 3 times x plus 3 all over, what is that? X plus 3 in bracket. Okay, so times 2 times 3, okay, times x. This is fun, man. Break things apart, man. And that will break that apart. See? So what do you have there? You have x plus 3 over, see that? 2x. That's it. There's nothing else we can do. Did I make a mistake? No, I don't think I made any mistake. So I think we did it right. Okay. We gotta find you more problem. Let's stop here for now. Okay. Now we switch to division, okay? So it says divide. All the stuff I'm gonna be showing now, we're doing division. You see the division sign there. Okay, so the first one, what is that? Remember what I said, division, you do the reciprocal of the divisor. The divisor is there. Okay, so you say 4 over 5 is the dividend. And then you say multiply, you do reciprocally. Reciprocal means you flip it. So it's 20 over 13, you see that, right? And then once you flip it, then everything now is like we did before with multiplication. So you expand stuff. 2 times 2 times, what is that? 2 times 10 times 2 times 5. You see that, right? Okay, so I hope you see what I'm doing. I'm not doing any magic. I'm just following the multiples. Okay, you have 5. Okay, this is messed up. I think there's really nothing we can do. 13 has no multiples, that 13. So we'll leave it like that. 5 cross 5. I don't think we can do much with this now. 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So basically 16 over 13. There's nothing we can do. Once you see that thing there, that 13, it's nothing you can do. It stop you cold, So let's go to the next one. This is the same thing as 7 over 8, and the reciprocal becomes multiplication right there. And then the rest are like we normally do. 7 times 2 times, what is that? 2. And it is 2 times 4, 2 times 2 times, what is that? 3. That's nothing else we can do. We must simplify that. We get 7 over 6. That's all we can do, man. We can't do more than that. It's nothing else anybody can do. We'll leave it like that. Okay, so we'll move to the next one. Look at that. That one is a little bit complicated, but it's not hard. In fact, I can see things canceling out. So let's use that trick we'll learn. But first of all, let's rewrite it. 9x raised to power 4, 3x raised to power 5 times 5x raised to power 3, 3x raised to power 2. So first of all, we'll put it in multiplication mode, and then it becomes 3 times, what is that? 3 times 5, and then x raised to power 7. You see what I'm doing, right? And it becomes 3. What did I do? I messed up. Yeah, no, it's okay. I didn't mess up. 3 times 3. What is there on the bottom becomes times x raised to power, what is that? 7. Okay, you see? You see that, right? Something funny happening there. This cancel out. Notice that I can write this. This is where you hone your skill. It's, how do you say that? Display the skills, This is 5, and then it's x, 7 minus 7. Like that. What is that? That's 5 x raised to power 0. That's something as 5, because anything raised to power 0 is 1. except you can't, if you can't except 0. If you raise 0 to 0, it's undefined. You understand, right? 0 to 0 is undefined, but that's the solution there. Okay, 0 raised to power 0 is undefined. This is undefined. It has no definition in mathematics. 0 to power 0, okay? So, but don't forget that. We're not worrying about that right now. But you need to know that. I've covered that when I did exponents. So if you have a problem with exponents, go watch my video on exponents. I did a detailed information. I gave you detailed information there. Okay, let's expand this. 35x raised to power 8 over 7x raised to power 9 multiply 9x raised to power 6 and then 5x raised to power 5. Now you expand it. Once you do the reciprocal thing, you expand it. Do you remember? You remember what I told you when we first started? You have to be careful what you're doing. So okay, so 5 times 7 give you 35, and then times 3 times 3, and then you get x raised to power, what is that? X raised to power, that's 10, 14, okay? I'm gonna play with that thing, watch this. 7, actually 7 times 7 is 35, but it's okay. We'll do 7 times 5, and then we'll do times x, with that x raised to power in the denominator, x raised to power 14. You see that? Look at that. It works out fine. So it's equals to, this cancel, those two cancel out. So we'll have 9x raised to power 14 minus 14. You see that? Same thing as 9x raised to power 0 that's 9. Because anything raised to power 0 is 1. You see it, right? See how we simplified that? Alright. So let's go to the next one. So we mess with that. Do the same thing. It looks like this one will be long. I want to make sure I do it right. Let's give ourselves enough space. We say 4x raised to power 4, 2x raised to power 5, multiplied by, flip it around, -6, alright, 2x all raised to power 3. So you start expanding stuff, man. You see that, right? It's 2 times 2 times, I'll leave the x for now, times -6. Well, I don't want to leave 6 by itself. Let's do it this way. Negative, let's say -1 times 2 times 3, okay? That's the reason why I do that. You'll see in a minute. And then x raised to power 4. In the bottom, what do you have? You have 2 times x. Well, let me leave x. Leave it for the last. Okay. You see, remember we talked about this, the exponent. That's basically like, let me write this like that. That's 2 raised to power 3 and x raised to power 3. Remember I talked about that earlier. That's part of the, I forgot what it's called. If you have two things, the raised to power, in bracket, raised to power 3, you have to break it apart. Each of them raised to that power. You see it, right? Okay. Now, let's cancel. We'll cancel some stuff out. All right. Let's cancel. I can cancel, but I don't want to confuse you. Let's cancel it gently. That way you see what I'm doing. Okay, fine. Okay, notice that that's 2 times 2 times 2 times 2, 3 times, okay? So if you cancel that, you cancel that, so 1, 2 is left. Okay? So 2 raised to power 1 is left there. Look at the x. You see the x, we can combine that one. I'm running out of space. So we just leave that -1. We'll leave it there for now. We'll say 3 times 3 raised to the power 4. And then it's over. What is that? It's a 2x raised to the power 8. You see it? Okay. So this is boils down to, it's going to be negative number. -3/2. And then x 4 minus 8. Please, I hope I'm not confusing you, man. Just make sure you see what I'm doing. 3/2 and then x raised to the power -4, which is the same thing as -3/2. Okay. 2, we can say 2x raised to the power 4. That's the answer right there. You know, it doesn't matter how you break it apart, that's what you're gonna get. You see it, right? I think I did it right. Anyway, that's what is going on, but I took a lot of space right here. Okay, so that what of that one? We do -12 x raised to the power 6 over 3x raised to the power 2 times, you flip it around, 27x over, okay, I'm going to simplify that thing up there. It's 2 raised to the power 3x raised to the power 3. You see, I just simplify as I go. Okay. Let's eyeball that. What do you get there? We just expand. You don't have to worry. Let's put that thing in bracket, the negative sign, okay? So it's a 2 times 6, which is 2 times 3, okay? And then what is that? 27 is 7 times 7. Well, 27 is, I think it's 7 times 3, okay? 7 times 3 is 2, no, 7 times 7. Hang on a minute, hang on. Yeah, sorry about that. It's 3, 27 is 3 times 9, okay? Yeah, 3 times 9 is 27, right? Yeah, 3 times 9 is 27, but you can reduce 9 again to right here. 3 times 3, okay? And then what did I dropped off x? So x, you add the x, you get, what is that, 7. All right. The denominator, what do? You say 3 times 2 times 2 times 2, and then times x raised to the power 5. Okay. Notice that a bunch of stuff cancels out. That cancels out. Okay. So you see what is going on there. Let's see what we have. You go like that. What is that? 3 times 3 times 3. 3 times 3 is 9 times 3. So it's actually 27, right? X, that's over 2. X, 7 minus 5. See, right? Okay. 27 over 2. X raised to power, what is that? 2. That's it, man. There's nothing else we can do. Oh, did I drop off the negative? Yes. It's negative. Sorry. I dropped off the negative. Negative is there. I dropped off the negative. Sorry about that. Negative is right there, okay? Don't forget the negative. I just dropped it off over here. It's right here. Okay. So we keep going. We did it right. So this one, what is that we're dealing with? We say 3 over 2x minus 6, yeah, times, we flip x minus 3 over 6, and we expand. It's 3 times x minus 3 over 2. What is that? 2. You gotta keep that stuff together. 2x minus 6. You gotta keep it together times 2 times 3. You see that this cancels that. There's really nothing else you can do, because you gotta keep that together. You gotta keep it in one piece. So that's x minus 3 over 2x minus 6. I don't think there's anything else we can do. Did I drop off anything? I don't think so, man. So really nothing else we can do, you know. We did the best we can do. What else can I do? Is there anything else I can do? I don't think there's anything else I can do. Did I mess up? Just give me a minute. Let me see. Give me a minute. Yeah, I think there's a mistake. Look at that. That can be written as 2x negative 3. See that, right? So if I come here, do it like that too. So I messed up. I'm going to correct my mistake now. I just noticed that. Let's correct it here. 2x minus 3, okay? This will cancel that. And that cancels that. And then what you have, let me see. Yeah, sorry about that. I just noticed, yeah, that doesn't look right. If it doesn't look right, just look at the thing, find out what it's doing wrong. That's actually one of, what is that? One of 4. You see that, right? That's 1/4, man. I messed up before, man, so I corrected it. So this is where I messed up. That's equals to that, you know. So I gotta find more problem. Let me stop and then we'll come back. Okay, let's do a couple of more problems and then we'll go to combine the, do combined multiplication and division. Okay. Now look at this one here. Look at it carefully. You will see that it's something similar to the stuff we've done before. So we'll go 2x over x over minus 1 times x plus 2 over x squared. Okay, we'll start expanding stuff. We just have to expand this stuff, man. We expand this stuff. What do we get? We get, let me see. So really nothing. We said 2 times x plus 2 over x minus 1. I think there's really not much we can do. X times x cos x. So really not much we can do on this one. It's very, it's limited what we can do. 2x plus 2 over x minus 1 and then x. I don't know what else I can do there, man. Even if you multiply it, it's not gonna do anything. So there's really nothing we can do. We'll leave it like that. We can write the x in front here. You don't write it below. Write it like that. Remove this one here because that looks awkward. But that's all we can do there, man. That's it. That's all we can do there. And then the next one will say x minus 3, okay? X minus 3 over 2. I'm going to expand as I go, but just watch what I'm doing. Over 2 times 3 times x, okay? And then it times x over x minus 3. You see, right? This will cross that out. Okay? And then this crosses that out. So there's not much you can do. Then it becomes, what is that? X minus 3 over 6 over 12. Okay, that's x here. Put x here. Like that. I don't think there's anything else I can do, man. There's really nothing much I can do. There's nothing else you can do. What did I do? Let me see. You crossed that out. Did I drop off something? This is actually, I'm sorry. I'm sorry, I messed up right here. This is 2. Where did I get that from? No, I made a mistake from here. This is 2 times, there's no 2 here. Okay, so this is 6 here, sorry. This is actually 6 here. Let me clean that up for you. I do too much expansion, made a mistake. So this is 6 here, like that. That's what we got, right, man? Okay, so let's do the next one. You always gotta check your work. Make sure you're not messing up. It's 5 times a. Well, let's leave it like that. We'll see. X squared. I see a difference of square here. 4 squared, okay? Times x minus 4 times x minus 4. I'm trying to do many things at the same time. I hope I don't mess up. And then x raised to the power 5. You see it, right? Now we can expand that more. Let me see. That's 5 times x raised to the power 3. Okay. Times x 4 times x minus 4. Okay, notice on the bottom you can say x minus 4 x plus 4, sorry. It's the same thing as times x raised to the power 5. Notice that they start crossing out. That cross out. So you have, alright. You have 5 x minus 4, okay, over x plus 4, like that, and then x. Okay, let me not go into too much. I can work it out quick. You see this x here and that x. So you get it. X, you're gonna get x here 2, let me see, 3, and x to the power 2 here. That's it. That's all. That's all you're gonna get. You can't do more than that, man. It's nothing else anybody can do. You can not do more than that. That's it. You see what I'm saying? I mean, I don't know what else I can do. Okay, so let's move on to the next one. What is that? Let's see. Again, we expand it. I expand as I go. This is, notice, this is 2, oh man, 2 times 2, 4 times 2, and then x raised to the power 4 over. This is difference of square right there. 5 raised to the power 2. You see that, right? Times x minus 5, x minus 5 over x raised to the power 7. You see that, right? Okay. So the difference, that's the difference of square will cancel, will expand. There's really not much on the bottom, so I don't need to expand that 8. I leave that 8. I leave the 8 the way it was. CD, let me see. You see the x raised to the power 4 will be cancelled by x raised to the power 7. So what you're gonna have is x minus 5, x minus 5, alright, all over. You're gonna have this x, this here took care of this one here. Okay, so you have x raised to the power, what is that? 4. What is the one on top? Okay, it's power 3. Okay. Alright. And then what is that there? See, difference of square, you get x plus 5 and x minus 5. That's the square difference of square. I made a video on that, so go check it out. This cancels that. So what do you get? You're actually gonna get 8 x minus 5. It's not really not much you can do. X cubed x plus 5. It's nothing else you can do. That's how the best we can do there. That's the best we can do. You can't do any more to stuff with this thing, man. So we'll go to the next one, knock it out, and then we'll move on to a different thing. So let's knock this out. I like to isolate the minus 1. Okay, I think it's gonna be like the other one we did. Just don't mess with the 8. Leave 8 alone. X raised to the power 5 over x. This is difference of square. Okay, times x plus 2, x plus 2. After a while, you begin to see things, x raised to the power 3. Okay, that's difference of square there. So I'm going to follow it to where it goes and expand it properly. That way you can see. Alright, let's go like that. Negative 1, 8x raised to the power 5. Okay, x plus 2, x plus 2. Alright, so we expand difference of squares, x plus 2, x minus 2. See that? And then take care of that one times x raised to the power 3. Okay, so let's do it. See, that would absorb that. So what you're gonna have is negative 1, 8, x raised to the power 2. Okay, and then this, let me see, this cancelled down, and then you get x plus 2 over x minus 2. So that one got absorbed by that, so basically if you rewrite this, write it properly, you get negative 8x raised to the power 2 x plus 2 over x minus 2. That's all. I don't think you can't do more than that. That's all you can do. You can't get anything more than that, man. You can't get blood from a stone. That's done. So let me, move to something else in a minute. Okay, let's do a couple of more problems, then we'll move to something else, okay? This one I said divide, multiply or divide. Whatever you see there, do. So the first one is multiply, okay? So we'll just move on the way we've been moving on. Alright? So basically, this last 1, 2, 3, 4, last 5 problems are a little bit difficult. You just have to apply everything we'll learn so far, okay? Alright. So what we'll do, we'll pull out 5. Let me see. 5x minus 3, okay, over, pull out 3x plus 3, okay? Alright. You multiply that out by, pull out 4x plus 3, and then pull out, what are you pulling out here? So you can pull out 6, but it's not going to do us no good. Let's pull out, we'll pull out 3 first. You get 2x minus, what is that? 3 times 3. No, 3 times 9 is 18. That's 9 here, but that doesn't help us anywhere. But you know what? Let's cancel, because we can multiply things out like that, but we can also cancel that. Alright, so we'll put 2, you can put 2 out. Let me see, what was that? 6. If we put 6 out, what you get? X minus 3. Yeah, I don't know why I put, let's put 6 out, sorry about that. Let's put that 6 out. Oh, sorry, we'll pull 6 out from there. we can put 6 as 6. That's x minus 3. Yeah, 3 times 6 is 18. Yeah, so that cancels that. So when you do that, what do you get? You get 5 times 4 over 3 times 6. Okay, that's interesting. 2 cancel that, you get 2. 2 cancel that, you get 3. Okay, so that's actually 10 over 9. You see that, right? There's nothing else we can do. Let's move on to the next one. This is division, so we'll say x. This is a little bit more involved. You'll see in a minute. I think it's more involved, man. X squared plus 4x plus 3 times x plus 1 over x. I flipped it, minus 1. Notice that those two will have to factor. This part here, we gotta factor both the numerator and denominator. Let's do it. Let's do numerator, okay? Let's do numerator. This is a way of, I'm just showing you how to do it. You don't have to write it out like that. So x, so that's 2. We want factors of 2. That way multiply, you get 2 plus 2. And then if you add it, you get minus 3. So the candidate, notice that the candidate is 1 and 2. 2 times 1 is 2. So we can do negative, negative. See? Negative 1 times negative 2 is 2. Negative 1 plus negative 2 is negative 3. So that's it right there. So the numerator will factor as this. See? Minus 1 minus 2. We'll factor like that. Okay? You see that, right? So we'll do... we'll say that's the numerator. You know what? Let's do the denominator first. We'll do, that's the numerator there. We'll do the denominator, okay? Denominator, what is that? Okay, we want, I think it's, you see 3? Factors of 3, 3 and 1. 3 times 1, you get 3. 3 plus 1, you get 4. So it's gonna be, that one is straightforward. It's gonna be like this. It's gonna be x, 3 and 1. So the factors are gonna be that. You see that, right? It's nothing there, nothing mysterious. So that would be like this: x minus 1, x minus 2, okay, over x plus 3, x plus 1 times x plus 1 over x minus 1. See how it works out? This take care of that. This take care of that. So what do you get there? You get x minus 3. I mean minus 2, sorry. You see what is left? X minus 2 over x minus plus 3. I don't see anything else left. You know, so we got that knocked out. We'll knock that thing out. There's nothing else we can do. We'll knock it out and we'll move on, you see. So let's move on to number 3. Let's see that. Look at that. See, it's a similar thing. Everywhere we got a factor, man. So let's use the space we have here. Everywhere we have to factor. We have to factor everywhere. No big deal. We'll do it. We've done it before. We can do it. Okay. Let's do the on the left side. Oh well, let's rewrite this first. We'll write it as 2x squared minus x because it's a division. Sorry, you can't mess with that. X. Okay, plus 5x plus 3 times 2x squared plus x minus 3, okay, over 4x squared minus 1. Alright. Okay, I can see that and there's a difference of square, but I will show you in a minute. Now let's do the Is there anything I'm missing? No. Okay, let's factor things, man. Okay, we'll factor this 2x squared minus x minus 1. We'll factor that one. That's this one here. We'll factor it like this, 2x x. Let me see, minus 1. Minus 1 times plus 1 is that. Let me see, what do we, actually we're going to take into consideration there. Minus 1 times 1 will give you that. Actually, let's switch it. This is plus 1. Let's put minus 1 here. You see why I did that? So if you multiply like that, you get plus x. If you multiply like that, you get minus 2x. If you add them, you get minus x. So that will work. So our factors are down here. Okay, so let's do the other one. Let's do this one here. It's a loaded distance, man. It's 2x squared plus 5x plus 3, okay? We do that, what do we get? 2x. And we'll have, let me see, 3. It's nothing we can do, it's just 3 and 1. Okay. I think that would do it, because if you multiply that, multiply that, you get 2x plus 3x, that's 5x, so that would do it. You see it, right? Okay, 2x plus 3x, that's 5x, okay. So what of this one here? What of this one here? Let's factor it. They loaded this one up, man. Minus 3. We'll factor that. What do we get? You get 2x, you get x. Okay, see if we get... Actually, if you get 3 here, you get 1 here. That's 2 plus that's yeah, that's, so you make these negative, because if you multiply like that, you get negative 2x, okay? You multiply like that, you get 3x. If you add them, you get x, so this will work. Yeah, you add them, you get that x there. So we got all this is a difference of, let's put all that together. We'll put all that together. What do we get? 2x plus 1 multiplied by x minus 1, okay, over, notice that 2x plus 3x plus 1, okay, times, what is that? 2x plus 3, I'm writing this one, okay, over, no, times x minus 1 over difference of, maybe, well, we need to do something there. Notice you can write this, that one as 2x squared plus minus 1 squared. So that becomes 2x plus 1 and 2x minus 1. You see that, right? Okay. Yeah, that's the difference of square right there. See, once you break everything, things will start crossing out. That crossed that out. Let me see. You gotta be very careful how you cross it out. This crossed that out. Okay, I don't see anything else crossing out. Let's you have to be careful. I don't see, so you have x minus 1 times x minus 1, that's double, okay, over x plus 1 and 2x minus 1. I don't see anything to cross out. You see what I'm saying? So I think we did it, man. I don't know, man. That one is a little it's a little confusing. You gotta be careful. If you're not careful, you mess up. Okay, here is our next problem there. Let's knock this out. Alright. This is division, so we rewrite it as multiplication. X squared plus x minus 6, x squared plus 4x, okay, minus 12 times x minus 1 over x plus 3, okay? Alright. So we're gonna factor that, and then we'll factor that. Let's factor that. If we factor the numerator, we'll have x over plus x minus 6. You have x, you have x, you have 3 and 2. And that this is gonna be negative, so you get x plus 3 times x minus 2 over, alright, so we'll factor the denominator. What is that in the denominator? Is factor that, what is that, 12 and then 4, so that can be let me see, probably 6 and 2 is 12, right? And then negative, let's say have x here, have x here, so negative 2 times 6 is negative 12. You add those, you get positive 4, so that's it right there. X plus 6, x minus 2, so that is I'm sorry, you multiply that with x minus 1 over x plus 3. Okay, so notice that cancel that out, that cancel that out. So what do you get? X minus 1 over x plus 6. See? That's it. So we'll move on to the next one. We're done with that one. What is this? That's number 4. This is number 5. Sorry. Number 5. Okay. So this is the last one. We'll move on to something else, okay? Yeah, when you after this, we'll move on to something else. That way we don't make this video too large, you see. So if we don't do that, the video may be like 7 hours or something. Okay. So we're gonna factor it. Well, let's say write it as a multiplication. X plus 4 times x minus 3 over x. See, that's a difference of square, right? 3 here, like that. No, 3 2, sorry. 3 2 like that, times x squared plus 6x plus 9 over x squared plus 8x plus 16. So everything needs to be factored, man. Okay. Everything gotta be factored. Let me see. Yeah. Every time in this problem gotta be factored, man. So let's start from the left. X plus 4 times x plus 4 times x plus 4. You see that, right? 3 times, then x minus 3. And then difference of square, x plus 3, x minus 3. Okay. And then multiply. We're going to factor that one. Let's factor this. We'll factor it. Let's use over here to factor it. It's x and the x. 3, let me see, 3 and 3. Okay, so yeah, that's it right there. It's x plus 3 and the x plus 3. Okay, we'll factor the numerator. What is that? What is the numerator? You factor that. What is that? X. Okay, 4 times 4 is 16, right? If you add them, you get 8. Yeah, that's it. X plus 4 and the X plus 4. Okay, see? So you start canceling things, man. This will cancel that. This will cancel that. This will cancel that. This will cancel that. You see it, right? Okay. So everything cancels except X plus 4. Okay. X plus 4 times X plus 3. You see it? We did it. So we're gonna go on and move on to something else, okay? Alright, now we're gonna move to adding and subtracting rational expressions. Here's how you do it. To add or subtract rational expressions with the same denominators, okay? You add and subtract their numerators and write the result over the common denominator. Okay, so pick up on this. What we're talking about here, rational fraction with the same denominator. Okay, the same denominators. There are 2 other instances when the denominators are not the same. I will show you a trick how to reduce it to having the same denominator, okay? And then there is a occasion where they have what they call opposite denominators. I will show you also a trick how to reduce them to the same denominator. If you get the 2 rational fractions to the same denominator, your problem is solved, okay? Alright, so let me show you in abstract format. So let's say you have, so what you're saying there, let's say you have, let's say, I don't want to do formality. Let's say you have, okay, 2 rational expressions, okay, to add or to subtract. Okay, you have the like this: let's say A over C plus, A over C and then B over C. These are 2 of them, okay? You have these 2 rational expressions. Okay, of course, C cannot be 0. We know that. So to add them, notice first that they have the same denominator. To add them, you go like the definition saying you do this. That's what that definition is saying. You do this: A plus B over C. That's what that definition is saying. Make sure you read it. See why it's saying that, okay? Read it, understand why it's saying that. That's what I just said there. I try to simplify stuff, the common language. I don't want to do it in abstract form. There's a way you use abstraction. It's not necessary. So I want you guys to understand what is going on, okay? So basically, they have the same denominator. See, C is the same denominator. You just add the numerator and put it over the denominator. That's why I said up there. So suppose you're subtracting, okay? Subtract. If you're subtracting, then what? Okay, if you're subtracting, you do A over C minus B over C. You do the same thing. Common denominator, you leave it like that, you subtract. That's what I said up there. Read that. Read what I say here. That's what I did here, okay? I did it here. I'll give you example. Using simple fractions, okay? Suppose you have 2 over 9 plus 5 over 9. What do? You do 2 plus 5 over 9. You see? It becomes what? 7 over 9. That's what my definition is saying. Now suppose you have 4 over 5 minus 1 over 5. What I wrote there say you do this. You just do it like that: 4 minus 1 over 5. That's all. Don't read anything into it. That's all he's saying. You subtract the numerators, you put the result over the common denominator. You add the numerators, you put the result over the common denominator. That's all that is saying. If you read too much into that, then you're gonna make mistake. Okay. Now there are two instances. One is when the denominators are not the same. Then another time they say it has opposite signs. I will show you how to deal with that. I will show you that now. Then after that, we'll go and solve a bunch of problems. Okay. Okay. Now listen carefully. There are cases where the denominators and of the two rational expressions you add in the denominators are not the same. Okay. So if it has different denominators, like here, this denominator different here and different, both of them are not the same. Okay, there are methods different books describe. They tell you find the LCD, find the lowest LCD of those two denominators. Okay, you can do it that way. I don't want to do it that way. I'm gonna show you a different way to do it. The way I like to do it. If you like to find the LCD the way the books describe it, go ahead. But I'm not gonna do it that way. Okay. So the way I'm gonna do it is actually better to show you than to describe it. Basically, what I would try to do in that case, I would choose one of them. Then if I choose this one, then I will try to reconstruct this denominator. I reconstruct it using tricks to make it look the same as that one. So if I choose this, I will rebuild C to be equal to D. So I'm gonna try to find a way, use trick to rebuild C to be equal to D. But I have to show you how I do this. It's easier to show you than to try to describe it with abstraction, okay? So let me give you two examples. That way you see, then we're gonna solve a bunch of problems on that too. So let me give you two examples. Okay, notice here is example one, right? Notice that those two rational expressions, they have two different denominators, okay? But if you look at it, sometimes it's not easy. Sometimes it's not easy to determine. I'm trying to avoid using LCD. LCD is the least common denominator. What happens? I found that it confuses a lot of students. Okay, but a lot of students don't like using it. There's always a way around it. You should look at those two denominators. I can rebuild that into that. Here is how I do it. I say 5. What can I multiply 10 to give me 30? I can multiply 10 with 3, right? 3 times 10 is 30. So then I say 3 over 3, okay, times 1 over 10. I can rebuild it like that. Notice that this has nothing. Because 3 over 3 will cancel out. But if you see that, if you multiply that, you get 3 over 30. You see that? Plus 7 over 30. Now you have equalized you have equalized the denominator. It becomes 33 over 7. You see? It becomes 10 over, I'm sorry, not over 7. 3 plus 7 over 30. 10 over 30. It will cancel out. It will become 1 over 3. You see that, right? So that's one trick how to do it. There is another trick. There is another trick I use. Like, okay, see what we got? 1 over 3, right? Look at that. But I will show you. That one is a little harder, but it works. Okay? We'll have 1 over what? What is that? 1 over 10. Let me show you. 1 over 10 plus 7 over 30. Okay? And the answer we got is 1 over 3. Watch this. what you can do is not the LCD, but it's part of the LCD, but it's not the least. LCD means least common denominator. Okay, that's all that means. Denominator. But there's a way you can find it. You find one, but it's not the least common. I'll show you. Multiply 10 and 30. What do you get? You get 300. And you put it down there. Actually, let me do it this way. That way I don't confuse you. You get 300, right? Alright. Well, yeah, that's what you have to do. You write it like this. Actually, you have no choice. You gotta write it at 300. Okay, and then you proceed. This is their common denominator. 10 divide 300. What do you get? You get 30. Alright? 30 times 1. Because 1 is over there. 1 over 10. And then you do the same thing with the other side. 30 divide 300. Remember, if you take 300, you divide it by 30. Notice what you get. You get 10. You get 10, okay? So you take that 10 multiplies 7, you get 70. You see it, right? Okay. So if you simplify this, well, let me write it the way you're going to see it. I want you to see it. 7 times 10. Okay, then you simplify this, you get 30 plus 70, okay, over 300, okay? And then keep going. It's, what is that? 100 over 300. Notice that. It's the same thing as 1 over 3. The problem is you're going to be working with big numbers when you do it like this. You'll be working with big numbers. Let me give you another example, okay? Let's do this one. Let me see. We'll do another example. Let's do this example 2. I don't know, is it example 2 or example 3? I gave you... Well, it doesn't matter. Let's call it example 2. It doesn't really matter. We'll call it example 2, okay? Alright. Let's say you have something like this. 1 over 12 plus 7 over 15. Notice that they don't have the same denominator. You see that, right? So you got problem here. According to what they say, use the LCD. You find the LCD of 12. Well, yeah, you find the factors of 12, and then you find the factors of 15, and you find which one they have in common. That's all. You find the one they have in common, and then you use it. You use it to equalize the denominator. That's what they want you to do. Okay? But what I'm saying is, if you solve that, using LCD, what are you gonna end up getting? 5 over 60 plus 28 over 60. You're gonna get it like that. How did you get that? Well, what they did there, basically they say 1 over 12 times 5 over 5 plus 7 over 15 times 4 over 4. You see what they did? They multiply that out, you get 5 over 12 times 5 is 60. And then 4 times that is 28. And then 4 times 15 is 60. You see that? So it's the same denominator. And you get, what is that? You get 33, right? You get 33 over 60. You see that, right? 33 over 60. That's the same thing. The same thing as, okay, let's do it properly. That's the same thing as 11 over 20. You see that, right? That's what they got. But we can do it a different way. But it entails using a large number. See, like we did here? You take that, you multiply that. Let's do it there, you see. Actually, let me make a space. I draw this here. It's up to you the way you want to do it. One involves using large number. So we'll have that there. We'll have 1 over 12 plus 7 over 15, okay? So what I'm saying, multiply 12. 12 times 15, what is that? Multiply 12 times 15. Again, it involves, if you use long multiplication, you get that. So it tells you using a large number. That's all. But it works. Okay, if you do that, you get 180. I will show you something too. Do that, you get 180. Check this out. Like I said, it tells you using large number. Then you do 180. I will show you something in a minute. 180. 12 divide 180. Right? 12 divide 180. What do you get? You get 15. So you say 15 times this one here. 15 times 1 plus. Okay. And then you say 15 divide 180. You take 180 divided by 15. What do you get? You get 12. You put it here, 12 times 7. Because under 15 there is 7 over here. So then what you do, you simplify. It's 15 plus 12 times 7. See, it entails working with a large number, 84, you see? Okay, 84 over 180, see? So what is that? You see the problem? You're working with a large number. 84 plus 15 is equals to 99, right? You say 99 over 180, see? That's the problem, man. You end up working with a large number. That's the problem. 84, yeah? Yeah, it's 99. Now you can split. How are you gonna divide this out to get that? So divide by, what is 99? Let me see. 99 divided by, if you divide that by, see, that's the problem. It entails working with a large number. You divide that by 11, you get that, but that's not what we want. Let me see. 180 divide that by, did I make any mistake? 15? 12 times 7, just give me a minute. 12 times 7 is 84, okay. Now, you divide 180, let me see, 180 divided by 20, what do you get? That's 9, no? 180 and divide by, okay, divide that, okay, I see what they did. Yeah, we did it right. Divide 180 by 9, you get 20. Divide 99 by 9, you get 11, you see? Sorry, I kind of spaced out. So you see the same thing they got here, see? But it works, but you see, it entails working with large numbers. Sometimes you get confused, but see, when it's small like this, you can build the way I built it. When it's small like this, it's easy to build it like that. Use a trick and build it like that. But when it's like this, it's sometimes it's impossible to reconstruct. When it's like this, sometimes it's better to use LCD. But if you don't want to use LCD, use that. You multiply those two together. Oh, by the way, another trick I want to show you is this. Go back. When we multiply it, what did we get? We got that. You see that, right? We got 180. But check this out. We got 180. Okay, we got 180 now. Suppose we divide 180 by 3. Divide 180 by, I'm going to divide it by a couple of things. Divide 180 by 2. 180 divided by 2. What do you get? You get 90. Well, 180 divided by 2, you get 90. Okay? Watch this. I'm just doing exploration with you. Now do 180 divided by 3. 180 divide, I'm going to show you something. Divide by 3, you get 60. Okay? Now suppose you do, suppose you do 180 divide by 9. What do you get? You get 20. But you see, 20 will not work with that. Yeah, it won't work. I think the least common LCD is that. The LCD is that, you see. So even if you multiply, you can divide it. Keep dividing it. This is not the LCD, but this will work too. Let me show you. 90 and 60 will work. If you use 90 or 60 the way we use the 180 here, it will work. Let me show you. Okay. Let me show you. So let's use 90 first. I'll show you. Let me split it into two. Split this into two. We use 90 and then we use, 60. Okay, if we use 90, what was that? We'll have 1 over 12 plus, what is that again? 1 over 12 and 7 over 15, okay? Sorry about it, 1 over 12 over 7 over 15. Okay, so we use 90. We say 90. Okay, 12 divide 90, what do you get? You see what I'm doing? 12 divide 90. But again, it involves working with a large number. 90 divided by 12, okay? Oh, okay, well, that one won't work because it involves fraction. So that one will work. Anything involves fraction, forget it. Let's use 60. We say 1 over 12 plus 7 over 15, okay? And then we say 60. 12 divides 60. You take 60, you divide it by 12. 60 divided by 12. What do you get? You get 5. 5 times 1. Okay, plus 15 divide 60 divided by 15. What do you get? You get 4. You say 4 times 7. You see that, right? So you simplify. You get 5 plus 4 times 7. See? That's what you have to do. 4 times 7. You have to, working with, it doesn't matter. You're still going to work with a large number over 60, okay? And then what is that? That's 30, put 33 over 60. See that? See? So you can avoid, you divide the whole thing by 3. If you divide both numerator and denominator by 3, what do you get? You get 11 over here. You get, you get 2, 3, yeah, you get 20. See the same thing we got before, right here. See the same thing we got before. Let me see, where is it? Right here. The same thing we got here. And the same thing we got, where is that? We got here. So, yeah, so you can do it that way. You can multiply and then try to split it up. Try to divide it up. You will still get the least common denominator instead of doing it the way they normally do it. So that's the way I like to do it. Let me give you another example, okay? Sorry about that. I'll give you another example. I think I'm rambling, but it's okay. I just wanted to show you how I like to do it. Let me give you this. Let's give you this. One of this example here. This is maybe example 4 or something. I don't know. Example 4. Suppose you have something like this. Suppose they want you to add this 2 over 3y. Now you have variable plus 1 over 4y. Okay, notice that they don't have the same denominator. Denominators are not the same, right? Now what do? Well, you can try to find the LCD, or you can just see. In this case, it's easy to solve. You know why? Because you can eyeball it. You can eyeball it. Notice that 3 there, 4 here. I can bet you that I can make both of them to 12. I can reduce both of them to a common denominator 12 by doing this. By multiplying 4 over 4, see? And then 3 over 3. Do 3 over 3. Notice what I'm doing. 4 over 4 will cancel out. It will be 1. cancel out here will be 1. So you change nothing. But if you put it 4 over 4 there, what you get 8 over 12y plus, look at that, 3 times 1 you get 3, 3 times 4y you get 12y. Now you see they have the same denominator. So you say 12y, then you have 8 plus 3. 8 plus 3 is 11, you see? And you're done. You see? You know, you can do it that way, and the answer is correct. So when you can eyeball it and try to equalize the denominator, do it that way than walking through the LCD, okay? Or the LCD. Because sometimes it's confusing that way. Let me show you another example. Another thing they say, well, I'll show you the other way when we come back. Okay, notice another variation. You know, first I showed you when the denominators are the same. Second, I showed you when they are different. I showed you the tricks to deal with them. But there's another occasion you may see something like this. The denominators are opposites. I'll give you 2 examples here. Look at example 1 here. Example 1, example 2, okay? Notice what is going on. You have something in the numerator, but if you look at the denominator, they're opposite by the sign. So the idea is to, you know, use a trick to make the denominators the same. Use whatever trick you want, especially the negative. Use negative numbers, okay? So like this one here, because I know this is proper. That's how we normally, this is the proper way of writing it. So in this case, you multiply this with negative numbers. You multiply negative 1 here and multiply with negative 1 here. You know, you notice that it changes nothing because they cancel out. So if you do that, what do you get? Watch this. If you do that, what do you get? You get x over x minus 2 plus, watch this. I'm just gonna ward this off like this. You get plus negative 6 over x minus 2. You see that, right? So you see that. So once you do that, then you add in. Now you're dealing with because if you multiply that, you multiply this with that negative 1, it will flip it. You will flip it into x minus 2. And then the top one, it will become negative number. You see that, right? You know, so once you do that, then you see you're working with the same, you're working with the same denominator. So it becomes x minus 2. Okay, but be careful with the negative numbers, though, because you're adding. There are many ways you can handle this. You can leave it the way, then handle it. You say x, right, plus, you can say plus negative 6. You see the same thing as x minus 6 over x minus 2. You see that, right? So be careful. Be careful. You know, you can from here, you can actually turn the problem from here into subtraction. Subtracting 2 polynomials, but it doesn't matter how you do it. The same thing here, okay? You see how they're opposite. I show you a second example. Then you say, normally, you know, this is normal. This is normal. You say x minus 7. Normally, well, you can also have 7 minus x, but we'll keep this as normal. I don't want to confuse you. Don't worry about that. We'll consider that that's okay, and then we'll turn this one. We'll turn this one into this one over here. Okay, so to do that, we use negative number. We say 3x over x minus 7 plus, you can ward it off. Ward it off. You say 5 times negative 1, okay, and 7x minus x times negative 1. Because if you cancel the negative, it changes not, but we want to leave it there. And then we'll continue 3x over x minus 7 plus, Remember our wall. We say negative 5 over, it changes when you multiply that, it becomes x minus 7. I hope you see that, because when you multiply 7 minus x like that, minus 1. So 7 times minus 1 becomes minus 7. Minus x times minus 1 becomes plus x. And then you can write it as x minus 7. You see that? That's what we did here. Okay? So let me clean I'm just trying to show you how we arrived at that. You should be able to see it by now, Okay, so we watered it off. Now you add. Okay, you have the same denominator over here. You see that, right? So you get 3x plus minus 5. It becomes 3x minus 5 over x minus 7. You see that, right? Yeah, that's it. That's it, you see? So once you get that done, that is fixed. It will help you fix it. Fix the opposite sign, So these are the stuff you need to keep in mind. And now we're going to solve a bunch of problems, okay? All right. Okay, let's solve some problems, okay? Solve a bunch of problems. See the first one. Now we're dealing with the same denominator. They are all the same denominators, so we'll knock that thing out and move on to something else. You remember what I told you when two rational fractions, whether you're adding or subtracting, when they have the same denominator, it's easy, The problem is when the denominators are different. So when they're the same, you just knock it out. You say 18 over here, 5 plus 7. Okay, then you gotta simplify. What is that? 5 plus 7 is that's 12, right? 12 over 18. You simplify. 6 can go in there. 6 go 2 here. 6 go there. 3. Okay, you simplify, knock it out like that and simplify it, okay? That's all. That one is done. You move on. Okay? Alright. So this is the same denominator, 24. 11 plus 7. You knock it out. What is that? That's actually 18 over 24. Then you gotta simplify it, okay? 3 go in there. No, actually, is it 3? Yeah, I would say 6. 6 go in there, 3. 6 go on this one and get 4. Okay, you see that, right? So we're done with that. We'll move on. Look at this one here. This one here. Denominator can be variable, so you do the same thing. Don't let that scare you. You just do the same thing you're doing with constant. You say x. Then 4 plus 7. Do the same thing. What is that? 4 plus 7 is 11, okay? 11 over x. It's nothing to be scared. That's what you need. You have there. Do the same thing here. This have the same denominator. Nothing to be scared right there. Okay, you add the numerator. 5 plus 1 is equals to 6 over x plus 4. So, see, when they have the same denominator, it's easy. You don't have to worry about anything. You just knock it out. Knock it out and move on, okay? So, look at the next one. You see the next one? Same denominator, x plus y. You add the numerator, x plus y. You see that, right? So, look at that. You see that? You see that they cancel out, that thing is 1. You see? So make sure you understand why it's 1. See? So that's why I say when you're doing this, everything you learn from the past, you have to use it. Look at that. This is y squared minus 16, the same thing. Okay, the same denominator, and then you get y minus. Okay, look at that. See that trick there? You're subtracting this, and then the other one is minus 2. The 4 is minus. So how do you deal with that? Then it says y plus 4 over y squared minus 16. Notice that we have to simplify that. Notice what is in the bottom. It's a difference of square. You can write that as y minus 4 over, like that. So it becomes y. Oh, sorry. I'm going too fast, man. It becomes y plus 4. Okay, and then y minus 4. That's difference of square. This will cross out. So what we'll have there, after you cross it out, what do you have? You have 1 over y minus 4. That's the answer right there. It's nothing to be scared of. You knock it out. Knock it out and move on, man. You see that, right? Okay. So let's deal with the next one. We kind of took all the space up there. Okay. See that? See the same denominator? It's going to take a bunch of space. Let's see. X squared minus y squared. I think it's the same thing we did before. It's difference of square. And then you say y squared plus x squared minus 2x squared. Look at that. It's becoming pretty right there. Look at that, man. You see that? It's kind of pretty, but it's kind of messy. All right. So look at it carefully. Let me see. Actually, I see something. You can write this as, watch this. The numerator, you can write it as, okay, x squared minus 2x squared. Let me see. Minus y squared. I forgot. I think there is something 2x squared. Okay, but I know the denominator can be written like this: x plus y over x minus y, like that. But what are we gonna do with the numerator? Numerator looks weird, man. That can be fixed, So yeah, what basically happen? You can. Oh, I see. Sorry. See, these two, I didn't need to write down. What is wrong with me? Look at it, man. Look at these two right here. Look at these two, this one and that one. It can simplify. Simplify that, it becomes y squared, let me see, minus x squared. You see? Because, subtract 1x squared from, well, you have 2x squared minus 2x squared plus 1x squared, so it becomes minus. Basically, there's 1 here, but we don't normally write it, so, so that's a difference of square again. So you can write that as, let me see, y plus x times y minus x, and then see what is under. X plus 1, y plus x minus y. Notice something. Notice that this and that are the same, because you can switch the thing is a commutative. You can switch it around. It doesn't matter which one you wrote first. And then notice, this one cannot be switched. The other one cannot be switched because there's no way you can switch it. So the answer is x minus y minus x and x minus y. That's the final answer there. You leave it like that. There's nothing else you can do. There's nothing else you can do. I don't know. Just give me a minute. Actually, we can do something. I just realized. I was just talking to you about that. See, even though I was talking about opposite denominator. This is opposite numerator and opposite denominator. So we're not done. You can write this like this. Check this out. Check this out. You can watch this. This is so tricky. Suppose you write -1 here, and then you pull it out, and then what do you get? You get x minus y. You see that? Make sure you see that. If you multiply that, you get that onto that numerator here. Notice that, right? Look at that. This cancel out, so it becomes -1. Oh man, this is very, very interesting. I hope you see that, man. It's just a trick, because if you pull -1 out, yes, you can pull -1 out. You see that, right? Yeah, it's hard to see, man. I didn't see it when I wrote it here. But you pull -1. You see, if you multiply that, let me show you. -1 times x, times y, the way it was before, y. Well, let me do it with that. Y minus x. Multiply that as what you get. You get -y positive x. The same thing as x minus y. That's what we did here. And you do that, you cancel. You gotta be able to see that you cancel out. The answer is -1. So let's move on. But anyway, that's what is going on there. Okay, see this one here, and we'll knock this out. Let's knock it out. I see difference of squares. Well, it's the same denominator, okay? So we'll write it a squared, even though it's difference of square, we'll forget about that for now. We'll come to that in a minute. And then we say 3a squared plus b squared minus 4a squared. Now let's simplify that stuff. You have 4a squared, so basically 3a squared. So you're gonna have b squared minus a squared. You see that? Because there are 3 here, positive 3, negative minus negative 4a. So you subtract that, you get that, and then below here you get this. I think this is another situation we have to pull out something. Watch this. Watch this, man. You see, it's like that one we did over here, man. It's like that one we did over here. Watch this. So this, you pull out, look on the top, pull out -1. You have a squared minus b squared over a squared minus b squared. You see that? And this will cross this out, you get -1. I hope everybody sees that, man. It's a trick, it works. You play that trick and it works, man. So we did that. Let's find some more problem to solve, okay? Okay, now we got, before we were dealing with rational expressions with the same denominator. Now we'll mix it up with different denominators. It says add or subtract, okay? Alright, look at that. See the first one? You got different denominator. How do you proceed? So like I told you, what I like to do, I take 20, okay? I take 20 and multiply it. You can find the LCD, but I take 20 and multiply it by, multiply 20 by 12. I know it's working with a large number, but there's a trick I usually do. 12 times 20, okay? If you multiply, that's 240, okay? Now check this out. Suppose you divide it by 2, what do you get? You get 120. Divide it again by 2, what do you get? You get 60. And notice that 12 and 20 can go into 60, man. So instead of working with large number, that 240, I work with 60, okay? You see that, right? So I can say, I will use 60 as the common denominator. 12 will go into 60. If 12 goes into 50, what do you get? I'm trying to make it that way I don't work with large number. 12 divides 60. You get 5. So I say 5 times 5. 5 is already there up here. 5 times 5 plus, okay, 20, 60 divided by 20. Of course, it will go. 60 divided by 20, I think it's 3. No, hang on. What happened? 60 divided by 20. Am I dealing with fraction? No, it's 3. Sorry. I thought I was dealing with fractions. 3. 3 times 3. 3 times 3, see? So that's it right there. That's what we're looking for right there. Okay, so what do? You get 25 plus 9 over 60, okay? Simplify, keep simplifying. What do you get? You get 20, you get 30, that's 30. Is that 34 over 60? Simplifying. 34 over 60, if you simplify it, right? What do you get? You simplify that further. You can keep dividing by 2 until you get what you want. Okay, 34 over 60 will go down to 17 over 30 because you divide that by 2, right? Yeah, 17 over 30. I cannot divide it anymore. So that's what we're looking for right there. So let's move on to the next one. This is the same thing, but you don't want to work with large number. Working with large number, you must well just go their way to find the LCD. You don't want to work with large. Let me see if I can harmonize it. No, there's no way to harmonize that. Actually, we ain't got no choice, man. We have to work with large number, man. But I noticed something though. Both 30 and 45 can divide 90. I don't know if you noticed that. So you always want to eyeball it. And then look at this. If I multiply 30 times 45, no, that's a whole large number. We don't want that. But I can eyeball it. You see, if you use 90, 30 can divide 90, 45 can divide 90. 45 divide 90, you get 2. 30 divide 90, you get what? Let me see, 0, you get 3. So we can use 90, okay? If you use 90, 30 divide 90, you get 3, right? 3 times 7. You get 3 times 7. And then 30 and 45 divide 90, you divide it into half, you get 2. So you say 2 times 2. What is that? Simplify, you get 21 plus 4 over 90, okay? 17 as 25 over 90. See? So once you do that, 5 can go into 25. 5 goes into 25, you get 5. 5 goes into 90, you get 18. So that's the answer right there, see? So I think that's correct. Look at this one. They have different denominators. Now, this is if you eyeball this, you just use what works. Whatever works for you. If I eyeball this, I can equalize those denominators by doing this. Remember I told you about this. I can do it this way. X. I want to turn both of them into 15. Okay, x times over 5 times 3 over 3. You see that, right? Plus 1 over 3 times 5 over 5. Notice that we didn't, we added or subtracted nothing because 3 over 3 would divide, that would be 1. 5 over 5 would divide, that it would be 1. So we didn't change anything. So we multiply that out, we get 3x over 15 plus 5 over 15. So you add the same denominator 15, and then you get 3x plus 5. Okay, you get, let me see, you pull 3 out. Don't forget you can pull 3 out. 3 out of x. No, sorry. You can, so 3 cannot be pulled out. You can't pull it out. I think that's the that's the answer there. There's nothing else. You cannot reduce. You cannot reduce it anymore, man. I don't see how you can reduce it anymore. I don't think you can reduce it anymore. That's 3x plus 5. How do you reduce that anymore? I don't think so, unless I made a mistake. Yeah, I don't see anything where reduce. So I think we're done with that. We'll leave it alone. I don't know what else to do. Sorry. I didn't mean to clean it. I want to circle it like that. Okay, look at the next one. You see the next one, the same issue. You see, when they are like this, look at that. It's just like the one we just did. So you use the same trick. It's exactly like the one we just did, you see. So you say 3, no, actually 5 first. Because you want to turn that into 15. 5 over 5, okay? Times 8 over 3x. Plus, then you say 3 over 3 times 2 over 5x. You see that, right? Okay. And then you say multiply all that stuff out. You see, you're going to end up working with a little bit large number, but so what? It's better than nothing. So it's 40 over 15x plus, what is that, 6 over 15x. Notice they have common denominator now, 15x. Okay, so you start adding the things on top. 40 plus 6, so it's 46 over 15x. I don't know if anything 3 can 3 go into 46? Yeah, I think so. 3 divided 46. Yeah, 3 can. No, actually, no. 3 cannot divide 46. You get fraction. So we'll leave that like that. We're done with that, man. We'll leave it like that. Say 46 over 15x. Okay. Alright, so the same thing here. See, when you have the denominator that are not small numbers, the tricks can work. You don't need LCD. See, look at that. Look at 4 and 6. What are you going to turn them into? You can turn 4 into 24, 6 into 24. Okay? So you say, what do you multiply with? Actually, see, you multiply 4 times 6, you get 24. So basically, you say 4 over 4, okay? Multiply that thing up there. Hang on. Let me make this a little, I don't know why I write so huge. That's 4 here. I write so huge sometimes, it's not good. I take up all the space. So 4 times 2x minus 6 over 4, okay? Plus, now you do the same trick. What do you multiply 24? 6 to get 24. It's 4. No. I think I messed up here. This is not 4, this is 6. 6 times 6, yeah, sorry. 6 times 6 is 24. Over here is 4 times 6, okay? Here I do 4 over 4 times x plus 5 over 6, okay? Sorry about that, I cannot misread that. So you multiply things out, you get 24 here. Okay, 6 times 4 is 24, then 6 times the stuff on top. 2x times 6, you get 12x. 6x times minus 6, you get minus 36, okay? Plus, you do the same over here. 4 times 6, you get 24. And then 4 times that thing on top, the 4 on top times the numerator over there, you get 4x plus 20, okay? So you keep going. Now it becomes the same denominator. And you add the stuff on top, 12x minus 36 plus 4x plus 20. You see that, right? So you do all that. Okay. If you simplify, keep simplifying, you get, I'm going to take more space here. You get, remember, look at 12x plus 4x is 16x, okay? And then, what is that? You do minus 36 plus 20, you get minus, you actually get minus 16, okay? You get minus 16 all over 24, okay? Now, notice something. Suppose I pull 16 out. Well, let me pull 4 out. 4, you got 4x minus 4 here, right? And then 24. Okay, if you do that, what do you get there? 4 divide 24, right? You want to cross that out. Okay, and I think it's 6. Yeah, it's 6. Okay, so then you get, let me see, 4x minus 4 over 6. We can pull 2 out too. Pull 2 out. I'm going to run out of space. If we put 2 out, it will be 2 over x minus 2 over 6. This will cross that out. You get x minus 2 over, what is that, over 3? I think we did it, man. Huh? Hang on a minute. No, I messed up. This is 2x. Because when you put 2 out, you have 2 inside. I caught that quickly. You see right there. When you put 2 out, oh man. See, because I'm running out of space, I'm messing up. You have 2x here. Okay, see it? Okay, so that's what you're gonna have. The answer gonna be 2x minus 2 over 3. That's the answer right there. So we're taking up all the space. Okay. Yeah, see, when you put 2 out of there, you gotta leave 2x. You can't just pull 2 and act like you pull 4. If you can pull 4, right? If you pull 4, then it will, well, it's not gonna help you because 4 won't do anything for you. So you leave it like that. Anyway, so let's solve this one. The same thing. We'll try to equalize the denominator. Let me see. This time we want to turn it into 15. So we're going to use 3 over 3 here. On this side on the left. X plus 2 over 5x, okay? Like that. And then 6x. Oh, I'm sorry. Well, we're going to use 3. Over here, we're going to use 5. 5 over 5, okay? 5 over 5, 6x plus 3 over 3x. So we want to make the same denominator. What is that? There would be 3x plus 2 all over 15x. And then the other one would be 5. Let's see, 6x plus 3. Alright, all over 15, yeah, all over 15x, yeah, all over 15x. So now it has the same denominator. Okay. Now notice something. We just have to add the stuff on top. The denominator, common denominator is 15x, okay. We said 3x. Yeah, we're gonna expand it. We got no choice. 3x 6 plus. When you expand that, what do you get? You get 30x plus 15. Okay, keep going. What is that? 33x plus 21 over 15x. You see that? Yeah, 33 plus 21. Yep. I don't know what you pull out. Yeah, you can pull 3 out actually. But what? Yeah, you can pull 3 out. Pull 3, you have 11x plus 7, like that, over 15x. 3 divide that, you get 5, okay? It will be 11x. I'm gonna run out of space over there. 11x plus 7 over, what is that, 5x. I think that's all the best we can do. We can't go further, man. It's nothing else to reduce, man. Yeah, I think we did it, man. We've been doing this for a long time, man. So we did a good job today. Pat ourselves in the back. All right, we'll continue. I think we'll have a bunch of them that I remember that one I told you, opposite denominators, okay? The denominators are opposite, so we'll try to, make them the same by using a trick. The trick has to do with negative 1. So look at that there. So we keep x minus 5, and then this one we change it by, let's ward it off. We'll ward it off by saying, let me see, we multiply by negative 1, okay? Multiply the whole down thing by negative 1. 4, okay, over another negative 1 on the bottom, okay, because if we cross them out, they will go away, you're not changing nothing. X minus 5, okay, so it becomes 4x minus 5 plus, look at what is inside that big bracket. You multiply that, becomes negative 4 over, let me see, if you multiply that, what the hell did I do? Oh, okay, I'm looking at the wrong thing. Hang on, what did I do, man? Actually, I messed up. I wrote it wrong. It's not that. I think I'm getting too tired, man. Look at that. So we're trying to change that one. So that one's supposed to be inside that bracket 5. I'm glad I caught it on time. Okay. So if you multiply, keep multiplying, what do you get in there? You get x minus 5. You see that, right? So now I did it right. Okay. So after you do that, man, what is wrong, man? I'm writing the wrong thing, man. It's 6. It's negative 6. Where am I getting 4 plus, man? I'm copying the wrong thing. I'm copying this one here, but that's not the one I'm using, man. So, alright. Let me make sure I'm doing it right now. I don't know what is going on. Let me see. Okay. Okay. And then we're going, let's see, okay. Alright. I think I'm on the right track now. I don't know. I think I'm getting tired or something. So it doesn't matter how you do it. You can keep putting plus here and then say negative 6 over there like that over x minus 5. Now you notice you're dealing with the same denominator. So you say x minus 5 and then you have 4 minus 6. You see that, right? That's negative 2 over x minus 5. That's what we got, man. That's it. The negative is on top. It's next to 2. Let me make sure you understand that. The negative is right here. It's next to 2 like that. Okay? So that's what we got. Let's move on to the next one. So the same trick. This time I need to pay attention. I don't want to be messing up. Okay. So we're gonna do the same thing. Play the same trick, man. I wanna let's switch this. Okay. So it's okay. We can do it. No big deal. So we'll say minus 1 over minus 1 times the first one. The first one is negative 1 over here, and then this one is 1 minus y. So we'll worry about that minus 4y minus 3 all over y minus 1. Okay. So we'll do that. What do we get? We get positive 1 over y minus 1. You see that, right? Minus 4y minus 3 over y minus 1. Notice it's the same thing. It's same denominator. So y minus 1. I need more space, so let me conserve space. Now why I'm writing so big? Y minus 1, same denominator. So I have 1. So don't forget this is minus. You're minusing the whole thing. You're subtracting the whole thing. So it'll be minus 4y minus 3, okay? Don't get confused about the sign. Alright. Let's do that. We get 1 minus 4y plus 3 all over y minus 1. So do that. What do you get? Yeah, do it carefully. You should get the right thing. Let me say 3 and that you get 4. Sorry. Oh Lord. So that's equals to 4 minus 4y over y minus 1. I think we can pull something out. I'm using up the space all over the place. Let's go up here, man. That way we don't use up the space for other problems. If we go up here, what is that? We'll pull out 4. You get 1 minus y. Okay, over y minus 1. Now we can play that trick again. If you multiply, that's interesting. If you pull out negative 1 from there, what do you get? You get negative 4, okay? And then you switch that thing. So you switch that thing. If you pull out negative 1, you switch it, you get y minus 1. And then this cross out. I'm laughing so loud. Okay, fine. So this is equals to that. It becomes equals to negative 4. I don't know if I did it right. I think I did. That's that trick we played before. So it becomes negative 4. You see that, right? Okay. I think we did it right. I don't know, man. We did it right. I think I'm catching cold. Sorry about that. I keep coughing. That's negative. Yeah, I think we did it right. I'm trying to figure out if we made a mistake. We just took a bunch of space. Let me make sure you don't get confused right there. See, that problem don't have a lot of space anymore. So we do the same thing. See, the same issue. We pick on one and move it around. Let me see. Let's pick on that one. Pick on this one. So we say x over 5x minus 3y. Okay? Minus, we'll ward that one off. Okay. What do we say there? We say, alright, say minus 1 over minus 1, okay? We multiply that with 1 over here. We multiply, what is that? 3y minus 5x, okay? So we keep going, x over 5x minus 3y minus, okay, don't forget our minus sign, we'll leave it there for now, don't worry about that. Say minus y over, what is that, 5x minus 3y, you see that, right? So we got the same denominator now. So we say it's 5x minus 3y, alright. What is that? Then it's x minus that becomes plus y. I hope you see that, right? So, alright. What is that? Look at the bottom. There's nothing to pull out at the bottom. Let me see. It's really nothing we can do. You can't pull anything out. Even if you pull something out from the top, and so what? You can't do anything with it. So we'll leave it like that. We're actually done with that. Because there's nothing else you can do. You know, you have to just leave it like that. You can't do anything with it. Okay. See, really nothing you can do. There's nothing you can do with that, man. You leave it like that, man. You know. So, but anyway, that's what is going on. Alright, so we'll do the next one. Like again, I kind of took up a lot of space right here. Okay, we'll do the next one. The same issue, man. So let's try to modify that one. So put it in this form here. Okay. So we keep going. We got plenty of space. So we said, I don't want to write it with red. Okay. 3 over 4x minus 5. Okay. Plus, I word this of 9 minus 1, or like that. Times minus 1 length. 5 minus 4x. Okay. Keep going 3 over 4x minus 5. Alright. Plus, let's fix that. Minus 9 over 4x minus 5. You see that, right? We'll transform that. So we'll get over here. So we've got the same denominators now. 4x minus 5. Alright. And then 3 minus 9. See? Keep going. It's negative 6 over 4x minus 5. I don't think there's anything more we can do. Basically, we got that fixed right there. There's nothing else anybody can do for that thing. See? What? Yeah, well, I mean, there's nothing else we can do. We got it fixed. It's okay. So we did it right. Alright. So we'll word it up like that. So the last one, we got plenty of space. Notice something. Maybe I do one. No, we'll do this one and move on to something else. Notice I'm going to switch this around. So we'll do 15x over 5x minus 7 minus, watch this, minus 1 over minus 1, okay, times 21. Just have to be careful. Don't mess anything up. Then when you multiply, just do stuff carefully. When you multiply things out, it will come out right. Okay, keep going. 15x over 5x minus 7. Okay, minus, what is that inside that bracket? It becomes plus. Well, we don't write plus in front of number. It becomes 21 over, what is that? 5x minus 7. Okay. You see that, right? 15, well, they got the same denominator now, 5x minus 7, okay? And then we got 15. We got 15x. I don't know what is that. It's okay. We got 15x, okay? 15x minus 21. See? We got plenty of space. What can we pull out? If we pull out, we can pull out 7, no, 3, yeah. You pull out 3, have 5x minus, what is that, 7. You see that? See the way they designed the problem? 5x minus 7. Alright, this will cross out, this cross out that. Okay, so the problem, you get 3. That's interesting. Did I do it right? See, pull out 3 times 5, yeah, 3 times, okay. So, we did it right, man. Okay. I don't know if we can do one more. How many did we do? 11. Let's do one more. Let's do one more. It's okay. We did 11. Let's do number 12. Okay. Number 12 is. Just give me a minute. Let me get it for you. Okay. Let's do this one. We'll do one more. And then we'll move on to something else, okay? Check this out. That's number 12 right here. That's number 12. So we'll keep that. We'll switch. Sorry. We'll switch that around. That's x. Sorry. I messed up. That's x right here. We keep that and we'll switch that around, okay? So we'll do 24x over 6x minus 5. Minus, we'll word this off, minus 1 over minus 1 times minus 20. You see how I'm doing it? You do whatever, but I like to write it out that way. There's no chance to mess up. You know, now that I have space, you see how I write big, because I got plenty of space. Now watch this, just follow it up. 24x over 6x minus 5. Okay, keep going with what you have inside that big bracket. Multiply things out, you get 20. Because negative 1 times negative 20 becomes 20, okay? And then this negative will switch things around. We'll switch it to x minus 5. You see, it will do the trick. You see that it absorbs it and then does the trick. Okay, so they have the same denominator now, so we'll do 24x over, I'm sorry, not like that. I want to make sure I get it right. See, they got the same denominator, is 6x minus 5, okay? Then 24x minus 20. See, that's what I want. Okay, so, and then we'll keep going. What is that? 24x minus 20, right? Let me see, make sure I did it right, yeah. So what do we pull out of there? You pull out of 4, see? And then it will match this one. Watch this. Pull 4 out of there. What do you get? You get, I think you get 6x minus, what do you pull 4 out of 20? What do you get? You get 5. Okay, well, 6x 5. You see that, right? This will cross this out. This will cross this out. And then the answer is 4. That's it. smoked it out, man. So we're gonna move on to something else, okay? Okay, notice, look at number 13. It's like the one I told you about. If I have, if you eyeball it, you can build something out of it, reconstruct the, they don't have the same denominator, but sometimes you see very, very easy to reconstruct the denominator to make them equalize the both denominator. Notice this, I can write this as 7/1, right? If I write that as 7/1, notice what I can do. I want to have this denominator on that side. So then what I can do, multiply x plus 4 over x plus 4 on that side. It means nothing because you cross it out is 1, right? So it changed nothing. So I'm going to leave it. I'm not going to cross it out. Then it becomes 3 over x plus 4 plus, you multiply that out. Don't forget about crossing it. I didn't cross it out, but if you cross it out, it changes nothing because it's just 1. You cross it out is 1. So then you get 7 times x plus 4 over x plus 4. See how they have the same denominator now? So that's the trick you play there. Equals to 3 over x plus 4. Actually, no. Let me do it this way. Sorry. So they have the same denominator, x plus 4. Okay? So then you have 3 plus 7. Let's multiply it out. Multiply that thing out with 7. What do you get? You get 7x plus 7 times 7, 28, right? See? 7 times 4 is 28. Okay, what is that? So you get 7x plus 28 plus 3 is 31 over x plus 4. You see it, right? Yeah, so we're trying to play that trick there to reconstruct what is going on there, see? Alright? So given that, I don't know what else we can do. We can't pull 7 out of in the numerator, 7s, we can't put it out because 7 cannot go into 31. So basically we'll leave it like that. We're done. That's the answer right there. It's nothing else we can do, so, but anyway, we'll move on to the next one, number 14. Look at that. I think it's the same. Let me see. They don't have the same denominator, so we'll have to find a way to find the same denominator. Okay, that's all. That's the idea there. How do we do that? What we need to do, okay, I'm glad we have this problem because we need to multiply both sides by the same thing, okay? So we'll multiply just like, remember when we had 1 over 2, we were adding it to 1 over 3. So to make them the same denominator, we multiply this with 3 to get 6, right? And then we multiply this with 2 to get 6 at the bottom. You see that, right? Okay, that's the same thing we're going to do here. It's just a little bit messy because it's full of variables. All right? So, what do we multiply? I don't even know. You see, remember when I told you about doing LCD? I said, like, if you have something like, again, let me use the same example I gave you. What was the example? Like I say, over 2 plus over 3, all right? I say you can take that, multiply that, like that. 3 times 2 is 6. See? Because the number is not like you can do it. Then you say 2 divided 6, you get 3. You say 3 times 1, like that. Remember? 3 divide 6, you get 2. 2 times 1. So, you remember that, right? Okay. That's another trick I use. That trick works here. Okay, it works here. So, look at, we want a denominator like say x minus 7 times x minus 3. Remember, that's what the example I just showed you. That's what that comes out to. We want something like this in the denominator. How do we get that? Well, what we'll do, we'll multiply 5x over x minus 7. We'll multiply it with x minus 3 over x minus 3. Like that. See? And then we'll do the same thing minus. The other side we'll multiply with that. We got 3x over x minus 3. Okay, we'll multiply with x minus 7. Okay, x minus 7. Because you can cross all that, you can cross this across, but that's not what we want. We want to multiply it that way. We have common denominator. Okay. So now we'll see we have common denominator. So we'll have to multiply everything out then. So it's equals to x minus 7. Okay, x minus 3. Okay, so they have common denominator right here. This one and that one. Okay. That's what I put down here. And then we deal with the numerators. Okay, 5x times x, you get 5x squared. 5x times 3, you get 5x, 15x. Yeah, you get negative 15x, sorry. Okay. And then what of the other side? That's minus. Don't forget it's minus. You put minus at there, make a bracket. 3x times x, you get 3x squared, okay? 3x times negative 7, you get 21x, okay? Don't forget the negative sign here. So we keep going. Alright, we keep going. What do we get? 5x squared minus 15x minus 3x squared plus 21x. You see that, right? Okay. All over the common denominator right here. X minus 7. X. So, what we're going to do, run out of space. We'll combine that. Combine the likes. Notice that you combine them, you have, let me see. You have 2x squared. Okay. Combine those two, you're gonna be negative 20 plus 21 else. You subtract 15. Okay, when you do that, what do you get? You see what I'm doing, right? It's no magic there. You gotta observe what you're doing, and then you knock it out. Okay, so that's 6x. Okay, all over x minus 7, x minus 3. So look at that. Look at that. What can we pull out? We can pull out 2. Let me see. If you pull out 2x from the numerator, what do you have? X plus 3. Is that 3x or 3? Yeah, I put that out, it's 3. But nothing will cancel, so what is the essence of putting that thing out? I don't think anything will cancel. Yeah, nothing will cancel though. So it's a waste of time pulling that thing out. I don't see anything canceling, so why am I pulling? I should have left it where. But you see, that's the answer, man. Because there's nothing else for us to do, so that's the answer. So we'll move on. We took all the space, man. We'll move on to the next one. Okay. See the same thing. So we're gonna conserve some space. But basically it's the same idea. Alright, so the same idea. We need to equalize the denominator. So we'll go 6x over x plus 4 times x plus 1 over x plus 1, like that, plus minus, I don't want to confuse, minus 2x over x plus 1, and then we multiply with the other one, x plus 4, okay, over x plus 4. I hope you see what we do. We're not changing nothing. We just multiply them like multiplying with 1. Okay, so we simplify that. What do we get? Now you got the same denominator, okay? X plus 4 and the x plus 1. So we multiply at 6x squared plus 6x, okay? You gotta be careful, minus 2x squared minus 8x. You see that, right? So we'll simplify. We're gonna simplify that then. Keep going, simplify it. Okay, we have the same denominator here. Leave it like that. We have to carry everything along with us. Okay, so you simplify that. Look at that. 2x squared and 6x squared. That will be 4x squared. You see that, right? Okay. Now the other one, my negative 8x plus 6x, it will give you negative 2x. Okay. You see that, right? So let's move over here. Grab more space. What will pull out? Let's pull out 2x. Can we pull out 2x? If we pull out, let me see. Yeah, we pull out 2x, you get x minus 1. Yeah, over x plus. I don't know what good it's gonna do because we have x plus 1 here. It ain't gonna do no good, man. Unless we make trick. There has to be a trick. Actually, yes, we can make the trick. We'll put negative sign here, and then we'll say 1, well, say x. We'll say x plus 1. That way this cancels out. Okay, you get negative 2x over x plus 4. You see that? So everything you learn, you bring it to bear. See, I think that's the answer, man. That's the answer there. We did it. We did it, man. Everything you learn, you bring it and put it into that problem, you solve it. You know, I don't know what we did. We did it right. I don't know if we did it right. What is that? So let me, alright. Yeah, I think we're done with that. We did it right. Let me move on to the next one. Look at that one there. That one, let's see. You have, if you look at it carefully, it's kind of, it looks like opposite, let me see, 2. If we get out 2 from there, what do you have here? No. They just have different denominator. I was thinking if you pull out 2 from here, let me see. You pull out 2 from here, what do you get? You get x minus, what is that, 3? It looks like the opposite of that one. It looks like the opposite of that one, but, I don't really know. Let's consider it different denominators. We'll try to equalize it. Even if I write it like that, what does it do for me? See what I'm saying? So, so we just have to find some kind of trick. I think this one we're gonna use trick. We consider these different denominators, and then we use trick to make it look like they're the same. So let's do it like this. Say 4 over let's do it like this. 4 over let's see, we just want to have the same denominator, right? Actually, hang on a minute. It's 4. Suppose we say 3 over x, okay? And then you say plus, and let me see, x over, suppose I pull that thing out. Even if I pull it out, 2x over 3, okay? 2x over 3. Can I play a trick? If I leave it like that, then I can work on that. Let's see something. Let's keep going and see what we can do. Suppose I put negative, let me see, negative 2 here over negative 2 here. What do we got? Watch this. Over 3 minus x, okay? Plus x over 2x minus 3. You see that? That's, I carried this over. But let's see if that will work. So you multiply that out, is negative 8 over, yeah, I think it will work. 2, you push the negative inside, you get x minus 3, like the other one. You see that? So you just do whatever that works. They have the same denominators now. You see? So basically, if you want, you can switch this around, right? X over 2x minus 3, yeah? Minus 8 over 2x minus 3. You can switch it around. There's nothing wrong with that. Okay, so they have the same denominator. So you say the denominator is 2x minus 3, and then you start adding stuff on top, x minus 8. I think we did it right. Now, say, what does that say? Oh, Lord. So what did, hang on a minute. Hang on. We just pulled that out. We didn't do anything. We pulled it out. This is where we did something. We multiply with negative 2 on top and negative, did I say negative 2 on the bottom? Yes, I did negative, yeah, right here. Okay, so we didn't do anything wrong. We did it right then. Okay, we did it right. So we get x negative 8 over 2 times, yeah. There's nothing else to do. There's nothing else. That's the answer right there. Sorry. That's the answer right there. That's perfectly okay. Okay, 16. Okay, that's 16 over there. I don't know what I did. Hang on. This is 17. Alright, so we'll do the same thing. It looks like that one we did before. See, look at it. They turned it a little bit upside down. Let me show you. Look at that. 5 over 4 minus x plus x over, look at that. If you put 2 out, you get x minus 4. You see that? So it switched around. So I can do the same trick I did over there, man. So you multiply that by negative 2 over here and negative 2, because it changes nothing. times 5 over here times 4 minus x over here, and then plus x plus this one, x over 2 x minus 4. So let's simplify that. That way we'll have the same, we're going to have the same denominator. Simplify that, you get negative 10 over, that multiplied that, you get 2, push the negative inside, you get x minus 4. You see, just like that one, 2x. So whatever you do that can work, you take it. Don't be scared. Nothing to be scared. You can even rewrite this if you wanted to. You can shift things around. What I mean, you can write it like this: x plus x over 2x minus 4 minus 10 over 2x minus 4. See? And then it becomes, look at that, the same denominator, 2x minus 4. And then x minus 10. That's almost the same thing we had before. It's nothing you can do. You're done. You can't do anything anymore, man. You're done right there. See? X minus 10 over 2. Yes, you're done. That's the answer, man. There's nothing else you can do. So let me see what else we'll have to do now. Okay, our next topic is equations involving rational expressions. There's really nothing unique about them. The only thing is that they contain rational expressions probably on one side or on both sides. So what you do, you just if an equation involving rational expression contains a fraction on both sides, just combine them. You combine them and then you use all the stuff we learned in the past, like a cross multiplication, all the techniques we learned, I explained in the past in various videos. You apply them here to solve the problem, okay? So there's really nothing to theorize about it. I will show you a couple of examples, and then we'll solve a bunch of problems, okay? So let me show you a couple of examples. Okay, let me show you a couple of examples, and then after that we'll solve a bunch of problems, okay? I just want you to see how I handle this. That way when we start solving problems, you know what I'm doing, okay? Look at that one. That's example number 1 there. Like I said, the trick is to use everything you know. Now you bring all your skills, so everything you learned so far, you bring it out. What I mean by that is, what you learned in arithmetic, what you learned in, from this class. This is algebra 1. Don't forget, after this we'll go into algebra 2, okay? Now, everything I have shown you so far, we did linear equation, we did exponents, we did all kinds of equations. So everything you have learned so far, you use it, you apply it. Okay, but this is not difficult. Don't be scared. I'm not talking like it's difficult. It's not difficult. So how do we attack this? Like I said, you combine each side of the equation. If you have to move things around, okay? It's up to you how you proceed. It doesn't matter how you proceed, you come out with the same result. When I look at this, you see I can move. You see the denominator in the left, x, the denominator is x minus 2. And then on the right hand side, it also has x minus 2 somewhere. So I'm going to move that because you see that's your q right there. That way you can easily combine the left side. So I will start by doing this x over x minus 2. And then minus, I move this one, this one to the left, 2x. Okay, keep track of your minus and pluses, and then I do that equals to 2. I would do 2 over 1, okay? I didn't change anything. You see that, right? Okay, now you see I can combine the left side because it has the same denominator. Alright, so I combine that like that, x minus 2 is equals to 2 over 1. See? Combining like that. Alright? I don't know if you noticed something. By the way, over here, keep in mind that x cannot be equals to 2, because if x is equals to 2, then you divide it with 0. So keep that in mind. Always keep that in mind. When you see some situation like this, all situations, you can never divide by 0, okay? Alright, so notice that I can cancel that out. Look at the left side, I can cancel it and get 1. So if I do that, basically if I cancel that out, it will be 1 is equals to 2, which is not true. Not true, man. You see that, right? Not true. So when you have a situation like this, it means there is no solution. No solution. That's what that means. Okay? No solution, okay? Alright, no solution. But I'm gonna continue. I'll show you something. Let's continue. Let's continue. That way you'll learn from this, okay? Another way to say no solution is say there's the solution of the problem is a 0 set, or it's an empty set. That's the solution set. Solution set, okay? Another way to say no solution. Solution set, empty set, or you use that, or you write empty set. But let me continue. I'll show you something. That way you learn something from here. Look at this. I can cross multiply. So we'll say 2, let me see. Cross multiply, what do you get? You get x minus 2 times 1, okay, equals to 2 times x minus 2. You see that, right? So let's multiply things out. You get x minus 2 is equals to 2x minus 4. You see it, right? Okay, no magic. All right, now I'm gonna move the like times to the same side, okay? So we'll do minus 4. Let me see, hang on, I'm going too fast. Minus 2 plus 4 is equals to 2x minus x. You see what I did, right? No magic. I just moved things around. So if you do that, what do you get? You get 2 is equals to x. You see it, right? But we can't have that. We can't have that, you see? We can't have that. That's a contradiction right there. Contradiction, right? You can't divide by 0. So you say there is no solution. Well, I don't want to confuse you. Basically, you said there is no solution. No solution, okay? No solution. That's a solution set. Solution set, empty set. Or you can write it like that, okay? That's why I had to explain that here. So this thing has no solution. So even if you cross it here, even if you cross this out, right here, you'll still end up with the same thing. But I just wanted to work it out. But anyway, let's move on, man. Sorry, I tend to be messy when I'm solving problems, but I can see what I'm doing. So there's no solution there. Solution set is 0. That's what that means. Always remember that. You learn that from there. If they say there is no solution, it means the solution set is empty set. The solution set is a set with no element in it. That means no solution, okay? So let's solve the second problem. Now, how do we handle that? Look at that carefully. It's up to you how you want to handle it. It's entirely up to you. But here's how I'm going to handle it. If you look at it carefully, you combine, see the left side, combine the thing together. We did it before, earlier. In the other topics we covered in this video. You use a trick to combine, make the left side have the same denominator. Those two rational expressions be added. You want to force them to have the same denominator. How do you do that? You multiply. You do it like this: 4 over 4. Notice that 4 over 4. What is 4 over 4? 4 over 4 is 1. And you multiply. I want to make sure you understand this. 4 over 4 is the same thing as 1. And if you multiply x with 1, it means nothing. You just get the same thing. You understand that, right? Okay, fine. Just making sure you don't think I'm doing magic. It's just a convenient way of trying to make stuff work out for us better. So multiply by 4 over 4. The first term there, x over 3, multiply by 4 over 4. The second one, multiply by 3 over 3. You just have to be able to see what you can use to multiply to, to have the same denominator. That's all we're doing. 10x plus x, okay? I mean 10 plus x. So you multiply that out, you get 4x over 12 and 3x over 12. You see that, right? Equals to 10 plus x, okay? My plus there looks funny, so I don't want to confuse you. Plus, okay, fine. So you see, now you can combine it. You have 12, the same denominator. You combine 4x plus 3x, okay? So equals to 10 plus x, okay? Oh, okay, now, what is that? You got 7x over 12 is equals to 10 plus x. Okay, now you can cross multiply. Notice that all this stuff can be written as like that, over 1. It's not necessary, but you can see it. Anyway, so we'll have 7x is equals to 12 times, see, 12 times 10 plus x. Okay, so you multiply things out. 7x is equals to 120, okay, plus 12x. You see that, right? So negative 120. I like to move things around and make it easier for me. And then you get 12x minus 7x. You see what I did? I moved this to the right, and then I moved this to the left. That's what I just did, okay? That's how I chop my stuff up. So, but anyway, you do that, what do you get? You get negative 120 is equals to, what is that? 5x. And then you say x is equals to negative 120 over 5. What is that? That's negative 24. That's it. That's all we're looking for. X is equals to negative 24. That's the solution there, okay? It's no magic there. We'll move on. Look at that. Look at example number 3 right there. You see it, right? Now you eyeball it. It's almost the same thing we just did. It's almost, see, look at that. It's almost the same thing as that one. You see right there? Almost the same thing. But it's not quite the same, but they have the same denominator. We'll have to equalize it. All right, so we'll proceed. We'll multiply this one 3 over 3, which is the same thing as 1, 3 over 4x, like that, minus, we'll multiply that one with 4 over 4, okay, alright, 2x over 3 equals to 1 over 2, okay, so we'll simplify, that will be 9x over 12 minus 8x over 12 equals to 1 over 2. You see that, right? Alright. Okay. So we'll combine 12, 9x minus 8x is equals to 1 over 2. Look at that. It's x over 12 equals to 1 over 2. And you cross multiply, okay? And then you get 2x is equals to 12. X is equals to, what is that? 6. See? No magic. That's what we found, okay? That's it right there. Okay, so we'll move on. What is the next one? I wrote it down. Yeah, number 4. You see that, right? Sorry about that, That's number 4 right there. Just give me a minute. Okay, so let's knock that out. What is that? Look at that. Again, the trick is try to combine things into one denominator, and then you cross multiply. That's all. You know, cross multiplication, we use that a lot when we did linear equations in one variable. Okay. So look at that. Like I said, there are many ways to do the same thing. You know, I combine the left side. You know, I can move things over, but it will just be a little bit more complicated. You know, actually, it's not complicated, but it's easier to just work what you have. We'll combine the left side. You use our trick. We'll multiply that. We want to make it the same denominator, which is 6. This is how we do. We'll multiply this side with 3 over 3. We'll multiply this one, 3 over 3, we get x over 2, okay? And then we'll multiply this one with 2 over 2, okay? I'm sorry, 2 over 2, x minus 1 over 3, okay? Like that, equals to 1. Notice that we change nothing, because if you cross out 2 over 3 out, you get 1. You cross out 2 over 2, you get 1. So change nothing. We added or subtracted nothing, okay? And then we'll simplify 3x over 6 minus 2 times x minus 1. You gotta keep track of things, okay? Use bracket. If it makes it easier for you, I like to use bracket. That way you don't make mistake, okay? Then over 6 is equals to 1. You see that, right? Notice that. Let me clean this. That way it doesn't confuse you. That's 2 right there. This is 2 right here, okay? 2 over 2. Alright, now notice that we can combine 6, 3x minus 2x minus 1. Now we can multiply that out, equals to 1. Alright, 3x minus 2x plus 2. You see? I hope you know why I did that, you know. Again, I have videos on that. Okay, let me do 1 over 1, which has nothing, okay? So combine the numerator on the left side. What do you get? You get x plus 2 over 6, right? It's equals to 1 over 1, okay? Alright, so you cross multiply, you get x plus 2 is equals to 6. X is equals to 4. That's what we're looking for. You see it, right? Alright, so we're done with that one. You see it, right? Okay. If you don't see it, make sure, keep looking, keep thinking, and you'll see what I did there. You know, sorry about that, man. I don't mean to offend. Okay, look at this one here. Look at this one. Eyeball it. What are you seeing there? I see something. See, this has difference of squares. It's called difference of squares, okay? I talked about that in one of my videos. Tell you how to factor that. So what we're gonna do, let's expand that. Maybe after we expand it, we'll start seeing something. 2x over. So difference of square, you can write this as x squared minus 2, like that. Okay, then you expand it. That would be x plus 2 and x minus 2, okay? That's difference of square. I talked about that in previous video. Then you get 1 over x minus 2 is equals to 2 over x plus 2. Now notice something. Notice that we can combine those, the left side. The left side of the equation, we can combine that. You know, the trick is to make this thing be like that thing. Okay, here's the trick. 2x over x plus 2, x minus 2, watch this. And then, you know, that's the same thing we've been doing with numbers. We'll do it with expressions, okay? When expressions are involved. And then we'll multiply by x minus, because we want to have that x plus 2 over x plus 2. You see that? Because that, if you cross that out, is 1. So you added nothing. You added nothing, you subtracted nothing, you see? Okay, so we simplified that, see? Now they have the same denominator, see it? Okay. So we simplified that, what do we get? They have the same denominator, and that is this here. That is x minus 2, see? So the same thing, they have the same thing. So you got 2x plus, what is on top of their x plus 2? See? Equals to 2 over x plus 2. You see it, right? Alright. Because you see, this is commutative. It doesn't matter if you switch it around. They're the same thing. So, but anyway, you see that, right? Okay, fine. Let's combine things. Combine the numerator on the left side. What is that then? You get 3x plus, let me see, did I make a mistake? 3x plus 2, right? Okay. X plus 2, x minus 2 is equals to 2 over x plus 2. You see that, right? Then cross multiply. I can see stuff, but maybe you cannot see it yet. I can see stuff. Cross multiply, you have 3x plus 2, okay, times x plus 2, alright, equals to 2 times x plus 2 and x plus minus 2. You see it, right? Notice that this crosses that. That's why I said, can you see that? I saw it from here. That can cross that out. Because if you divide both sides with that crosses out. I can even see it from here, from here. But it's okay. If you can't see it from there, you see it from here now. If you divide both sides with that thing I just crossed out, it will disappear from both sides, okay? And then we'll have 3x plus 2 is equals to 2x minus 2. You see it? So let's expand the right hand side. That's 2x minus 4. 3x plus 2. You see? So we'll combine. We'll move like things to the same side. So we get 3x minus 2x is equals to minus 4 minus 2. So what is that? X is equals to, right? Minus 6. We're done. You can't do anymore, man. We're done, man. We're done. So these are the examples I want to show you. Now we're going to go solve a bunch of problems on equations, okay? Equations involving rational expressions. Alright, we're going to solve a bunch of problems now. That's the first problem there. Okay, so you notice what is going on there. It's almost the same thing we had before. We've seen this before when I did the examples. So you combine the left side and then you cross multiply. So how do we combine the left side? We want to make the numerators of those two rational expressions. We want to make the numerators have this. I'm sorry. We want to make the denominators to be the same, to have the same value. Okay. So if the denominators have the same value, right, then our problem is solved. So how do we do that? Look at that. I can see we can turn both of them into 6. Each expression should have 6 as the denominator, okay? So how do we do that? Here is the trick. You multiply the first one with, let me see, 2 over 2, okay? Multiply the first one with 2 over 2. And you multiply the second one with 3 over 3, okay? Alright. Let me see. Don't get confused the way they wrote the problem. It doesn't, see. Okay. So you multiply that out. What do you get? You get 4x over 6 plus 3x. You see that over 6, okay? Is equals to negative 7. Alright, now you see, they have the same denominator. So you combine them 6, 4x plus 3x is equals to negative 7. I will say over 1, okay? I didn't change anything. Alright, so you combine stuff, you get 7x over 6 is equals to negative 7 over over 1, sorry. So you cross multiply. What do you have? You have 7x is equals to negative so you see, multiplying 7x, you multiply that with 1, yeah? And then you multiplied, on the other side, you multiply 6 with 7. You see it, right? Okay. And then that would be 6 times 7, that would be 42, okay? So we get, let me see, 6 times, 6 times negative 7 is negative 42. You see that, right? Then x is equal to negative 42 over 7, which will give you negative what? It will give you negative 6. I mean, we're playing tricks with numbers or something. We just multiply. Actually, I know what it's going to, but it's okay. I see it. Okay, so what we're looking for is x equals to negative 6, okay? That's what we're looking for. That's the solution we're looking for, okay? You remember I talked about solution set. If you want to say, you can say the solution set, okay? It's up to you. But that's all you need to do there. We're done. You can say solution set, okay? Solution set is this set. It contains the number 6. Okay, remember when we said the solution set is empty set, means it has no solution. Nothing there. So we're done with that. Let's move on. Alright, look at that one. You see that one there? Look at it. What we need to combine? We need to combine the left side. Don't get confused, man. Let me see. Yeah, we still have to combine it though. We still have to combine that. Let me think now. If I move this over. Not necessarily. You don't have to really, look at it carefully. You don't have to do too much if you don't need to. Look at this. If I say 4x over 7 is equals to 1 minus x. You see that, right? You can say x over 1, you see? So you don't need to do too much if they don't require you to do too much. Then you cross multiply, you get 4x is equals to 7 times 1 minus x. The same thing as 7, the same thing as 7, you multiply that out, you get 7 minus 7x. You see that, right? So you move the like terms to the left, so you get 4x plus 7x is equals to 7. You see it? So that's 11. 11x equals to 7. X equals to 7 over 11. 7, 11. So that's the solution there, man. It's nothing else unless I made a mistake somewhere. So yeah, there's no mistake in the previous problem. So here is the next problem we have. Look at it carefully. There's really nothing to do. You just have to cross multiply. You see, you can see that, right? Yeah, when you have it like this, just cross multiply like this. X minus 1 times 3 equals to x plus 3 times 4. I just cross multiply it, okay? Alright, so you multiply that thing out, you get 3x minus 3 is equals to 4x plus 12. Alright, so you move the like terms to the same place. You got negative 3, negative 12 is equals to 4x minus 3x. You see it, right? And then you simplify, you get negative 15 is equals to, what is that, x? Yeah, X is equals to negative 15. I don't know what else to do. We're done. It's nothing else to do there, man. So we'll move on to the next one. That's the next one right there. Look at it. The same thing, man. These are simple problems. I don't know why I chose these. They're just too simple. You know, I should have chosen something a little bit more complicated. Anyway, we'll solve it. You see, the same problem we solved before. We'll just solve it. We'll knock it out and go, man. We'll just cross multiply and go. You cross multiply, okay? Because you see, there's nothing else you can do. There's no other way to proceed. You know, you just cross multiply. You say 16 times 3x plus 6 is equals to 8 times 3x minus 3. See? Cross multiply. What is that? You know, I hope you see what I'm doing. That's nothing you can do. You just have to cross multiply and go. It's nothing else to simplify or anything else to add to it. You know, you just cross multiply. If it's easy, yeah, that's good. It's easy, just do it. You see, so, okay. So we do that, we get 48x plus, you see what I'm doing, right? There is something we could have done too. Let me show you. Instead of working with big numbers, we could have done something. Let me show you. Let's go back. Sorry. Let's go back. Let me do it this way and then I'll do it the other way too. Okay, let's keep going. I will show you the other way after I'm done with this way, okay? So it's 96 here. It's equals to 24x minus, what is that? 24. Okay? You know, let's see. We'll move things around. 48x minus 24x is equals to minus 24 minus 96. You see that, right? So you combine stuff around. You combine stuff. What do you get? You get 120 here. And then on that side you subtract. What do you get? You get 24x, okay? And then you say x is equals to, what is that? 120 divided by 24. You see that, right? Okay. And then you get 5. You see, so we work with big numbers. We just work with big numbers. What did I do? Oh, no, I'm sorry. It's negative here, negative 5. Sorry about that. I dropped the negative. Okay. But you see, we worked with big numbers here. We could also, I could have crossed things out. Let me do it over here. I'll show you. I'll take a space here. You know what? Let's say x equals to negative 5 here, and we'll remove that. That way I have space on the other side, okay? So this is x equals to, that's the solution, okay? But you see, we could have done it a little different. It's up to you. Let me do it differently using the little space over there. Okay, use this space here. Okay, look at that. I'm gonna write it in red. 3x plus 6 over 8 is equals to 3. What is that? 3x minus 3 over 16. Watch this. Suppose I multiply both sides with 8. Okay? If I multiply both sides with 8, what happened? Multiply this with 8. Watch this. Okay. Multiply that with 8. 3x. I don't want to run out of space. over 16, okay. Okay. Notice that 8 crosses 8 here. 8 crosses that, you get 2. Okay. So you will have 3x plus 6 is equals to 3x minus 3 over 2. See that? Let's say this over 1. See, that eliminates working with large numbers. But you see this, we're going to end up with the same thing. Watch this. So we'll cross multiply, we get 2 times 3x plus 6 is equals to 3x minus 3. Okay? Okay, keep going. You remove the bracket, you get 6x plus 12 is equals to 3x minus 3. You see that, right? Okay. So now see, what it does is make us work with small numbers instead of working with all these large numbers here. Alright, so notice what's going to happen. We say 6x, man, we'll bring 3 to the left. And then we'll take it 12 to the right hand side. Minus 3 minus 12. And then we'll simplify, we'll say 3x equals to minus 15. You see it, right? X equals to minus 15 over 3. So x is equals to minus is a 5, yeah? That's the same thing we got right here. So it's up to you, man. You can, if you see something you can eliminate by multiplying with something, do it. Don't be scared to do it. It will work. Let's move on to the next problem right there. You see, our next problem is similar to what we have done before. I don't know why I chose easy problems. Anyway, so let's solve it. There's nothing you can do, man. You cross multiply. You don't have to reinvent the wheel. You just cross multiply. So this is nothing else you can do. So actually, no, I take it back. You remember what I just said? If you see something you can knock out that way, don't work with large numbers, do it. So here, let me multiply by 5. Multiply everything by 5, man. Okay? Let me show you. 2x plus 1 over 5 equals to 7x plus 5 over 15. You multiply everything by 5, okay? Multiply everything by 5. If I remove that big bracket, you know what's going to happen? I have 5 times this one, 2x plus 1 over 5, okay? Equals to 5 times this one, 7x plus 5. Alright, well, let's do it like we did the other one, over 15, okay? So, notice what's going to happen. 5 will cross out 5, we get 2x plus 1 is equals to, on the other side, we can write this over 1, it doesn't matter. On the other side, we get, what is that? It's 7, right? The way I write, 7x plus 5 over, what is that? See, this will cross that and you get 3. You see? So we just want to work with small numbers. Now you cross multiply, you get 3 times 2x plus 1 equals to 7x plus 5, okay? Okay, so you multiply things out. Let me see, yeah. You get 6x plus 3 is equals to 7x plus 5. You keep going. You move things around, okay? You say, let me see. You say 3 minus 5 is equals to 7x minus 6x. You simplify, okay? You get minus 3, minus 2. Let's make it clean, nice and clean. Minus 2 is equals to x. That's it. That's what we're looking for. Is that minus 2? Yeah, yes, minus 2. Right? That's what we're looking for, man. We're done with that one, man. That's what we're looking for. That's it. Okay? Okay. You see the next problem there? I gotta expand this a little bit. Okay, here we go. You see the next problem there? Yeah, this is a little bit more involved, and not the other one. You just cross multiply. Let me see. Actually, yeah, I will combine the left side. Let's combine the left side and then leave the right side alone. Notice what is going on there. The strategy is to get the two rational expressions on the left, get them to have, you force them to have in the same denominator. Once they have the same denominator, then everything else is easier to handle. Okay. So how do we do that? Look at it carefully. We can force them to be. See, the one with denominator 5, I can force it to have denominator 10. You see? By multiply it by 2. How do you do that? Say 2 over 2 times 3x over 5. You see? I didn't change anything. It changes not. I changed nothing. You see that, right? Because you cross 2 with 2, you get 1. So, but anyway, that is, what is that? 6x over 10. You see it, right? X over 10 equals to x minus 6. In fact, I can just say this over 1 over there. So we'll combine the left side. You got 10 here. And then it becomes 6x minus x equals to x minus 6 over 1. You see? Okay. So it becomes, what is that? You subtract that x. It becomes 5x over 10 is equals to x minus 6 over 1. You cross multiply, you get 5x is equals to 10 times that. You multiply that out, you get 10x minus 60, okay? Alright, you combine stuff, right? You combine stuff, you get 60, move 60 to the left, you get 10x minus 5x. Which is the same thing as 5x, okay? And then it's x equals to 60 over 5. What is that? You see what I'm doing, right? Not doing any magic, man. It's going to be 1 over here, and then the other one is going to be 2. It's going to be 12. So x is equals to 12. So we're done right there. That's what we're looking for, man. There's nothing else there to do. Okay, and then we'll move on to the number 7. You see it there, right? This is the same thing. Look at it carefully. Actually, we can move things around. See, look at it carefully. Let me see. Notice that all the denominators are numbers. Okay, all the denominators are numbers. So we can do whatever we want with them. Okay? We can basically do whatever we want. So what I'm gonna do, I can even, you see the one that has it on the left? The one that have denominator 2, I can change that too. I can change that. Let me change that. You change it by multiplying 2 over 2, okay? X over 2. I'm sorry. And then you say sorry about that. You say minus x over 1. 4, okay? So equals to 5 over. There's always many ways to accomplish the same thing. So you say 2x over 4 minus x over 1, 4 is equals to 5. I'm just recopying stuff. Just too many writings, oh man, too much. Okay, so you combine the left side. Now they have common denominator. It's 2x minus, be careful, man. X minus 1. You see, you gotta put bracket there that we don't get confused, because you're subtracting the whole thing right there, okay? Don't get confused, man. Let me clean this up a little bit. That way you don't get confused right there. Okay, so equals to 5 over 4. So let's combine the left side, right? We take care of the numerator on the left side. We have 2x minus x plus 1. You see it, right? If you don't understand what I did there, just go to I have a arithmetic class. Go through the videos there. You will learn a lot. Okay. All right. So we'll combine. What do we get? We get 2x plus 1 over 4. Not 2x. Sorry. I didn't actually combine anything. I'm just messing around. It's x plus 1. See? It's equals to 5 over 4. You see it, right? Okay. And then we'll cross multiply. What do we get? We get 4 times x plus 1 equals to 4 times 4. You see 4 times 5, sorry. You see it, right? I'm gonna move it over here. That way I have more space. I'm running out of space there. So we'll move it over there. What do we get? We'll multiply things. I get 4x plus 4 is equals to 20, okay? And then we get 4x is equals to 20 minus 4. Okay. We get x equals to, we get 16 over 4. We get x equals to 4. That's it. There's nothing else we can do, man. So you see it, right? All right, so let's go to the next one. See right there? If you eyeball it, it's almost the same thing. We'll try to combine the left side. If you see the numerator on the left side, they're all variables, okay? And the denominators are numbers. The trick is to try to make them have the same denominators, okay? So to achieve that, I'm going to transform them to have 15. Or those two rational expressions on the left. I want each of them to have 15 as denominator. Well, how do I do that? Well, we'll do 5 over 5, okay? Times the first one. You see that, right? And then we'll do 3 over 3 times the second one. Yeah, you gotta be able to visualize, see what you need, and then you create it. What we're doing, we're building the denominator. We're building in that way it's convenient for us. We don't want to suffer. We'll make it easy. That way we don't suffer. Okay? So we multiply things out. What do we get? You get 5x right there, okay? Over 15 plus 3 like that over 15. You see it? It's equals to 7 over 3. You see it, right? Okay, fine. Now we'll simplify things, man. First, let's try to combine 15 here. We have 5x plus 2 plus 3x minus 5 equals to 7 over 3. You see it, right? So let's combine the numerator of that on the left side. What do you get? You get 5x plus 10 plus 3x minus 15. You see it? Over 15, okay. 7 over 3. So you combine things there. What do you get? You get 8x minus 5. 8x minus 5. You see it? Over 15. It's equals to 7 over 3. You cross multiply. I'm going to run out of space again. You get 8x minus 5 times 3, okay? Equals to 7 times 15, okay? You see, I'm gonna run out of space again. Let me draw the line. Draw the line in the sand. I'm gonna have to move this over. Yes, too many writings, man. Too much. Move it over here that way. We'll move it over here. Okay? That way we can use that space there. Alright, don't get confused, man. Don't get confused. Okay. So we'll see it's 24. We multiply things out. 24x, okay, minus 15 is equals to 105. 7 times 15 is 105, okay? Okay, so we do 24x is equals to 105 minus plus 15 actually, because we're moving 15 over, right? Alright, and then we end up with x equals to, that's 120 there, 120 divided by 24. We've seen that before, okay? That's actually 5. X equals to 5. I don't think I made any mistake. You know, see, it's too much writing, but we did it right. A lot of writing. A lot of writing. Hang on a minute. What did I do? Let me see. That's yeah. Just give me a minute. Yeah, we did it right. So let's move on to the next one. What is the next one? Right here. What is that? Look at that. So it's similar, man. Look at the left side with all the variables in the numerators, right? The two rational expressions got variables in the numerator, so we'll leave it like that. But we'll have to find a way to make both of them have the same denominator. Notice something. Notice 6, 8, and 4 comes. If we multiply the whole side by 2, yeah. Let's multiply everything by 2. That way we'll get rid of some numbers, okay? So multiply everything by 2 like that. Multiply by 2 like that. What do you get? You get x minus 6 over 3 plus x plus 2 over 4 equals to 11 over 2. You see that, right? I just shaped up some numbers. All right. Okay. Now, you shave off some numbers. Now we'll make this the left side to have the same denominators. We're using our trick. We'll say we want it to have both of them gonna have 12 as denominator. So we'll start with 4 over 4 times x minus 6 over 3, okay? And then we'll say 3 over 3 times x plus 2 over 4. Okay, we changed nothing. Notice that we didn't change nothing because you can cross things out. Yeah, if you cross 3 out, cross 4 out, you go back to where it was. So we didn't change the identity of the stuff there, okay? Alright, so we then multiply at 4x minus 6 over 12, 3x plus 2 like that, 12 equals to 11 over 2, okay? And now we'll combine the left side because we will have now common denominator. We'll combine them. I'm gonna start multiplying things out, man. 4x 4 times 6 is 24, okay? Plus, what is that up there? 3x plus 6, okay? Okay, I hope you see what I'm doing. I'm trying to save space because I can write it out and start all over again. You see what I'm saying? You know, so I'm trying to save space. is equals to 11 over 2. So we'll combine all that stuff up there. Okay. You see what's going on? Let me see. Combine it. You have, let me see, 7x minus, see, 18, okay, over 12 is equals to 11 over 2. You see it, right? All right. Okay, so we'll cross multiply. We'll get 7x minus 18 times 2 equals to 11 times 12. So I'm gonna run out of space. I'm gonna have to move this stuff up a little bit. Yeah, move this over here. That way I have more space. Move it over here. I move it over there. I keep running out of space, man. Okay. So we'll multiply things out. What do we get? We get, let's see, we get 14x minus, hang on a minute. So we get that 14x minus 36 equals to 132. You see that, right? All right. And then we say 14x is equals to 132 plus 36. Okay. All right. We get 14x is equals to 168, and then x equals to, all right, 168. I don't know, it looks weird, man. 168 divided by 14. Okay. That'd be big number, man. 12. I think we did it right. So yeah, that's okay, man. Just too much writing. Okay, we'll move on to the next one. That's number 10. Number 10. So look at it, eyeball it carefully. What do you see there? I think it's pretty much the same. We'll combine the left side and then we'll cross multiply. That's it. Those are the two steps we'll have to do. Look at it. Is there anything? I can't cancel. I can't reduce the numbers by multiplying with something. So basically what's gonna happen, it's I'm gonna have to use, let me see. Yeah, so my target is to get a denominator that is 4. It's both of them gonna have denominator of 42. So we use our trick. We say 6 over 6 times that and there, like that. Okay, and then we say 7 over 7 multiply with that and there, 6. Okay, it's equals to 1 over 6. And then when we multiply this out, we get 6x plus let me see, 6x plus 18 over 42, okay, minus 7, okay, don't get confused, 7x plus 14 over 42. So don't the negative sign there between them is still where it's supposed to be. So don't get confused with that. Okay, it's equals to 1 over 6. All right. So I'm keeping my eye on that negative sign. It's where it's supposed to be. So if it makes you feel better, put something like that. Okay. Now they have the same denominator, 42. And then you have 6x plus 18. Now you gotta subtract. You gotta be careful. Basically, it's like this: subtract 7x plus 14, okay, like that. So you don't want to mess up there. That's where a lot of people, a lot of students make mistakes. They confuse, they remove the bracket and then they make mistake. The bracket has to be like that. And then you simplify 6x plus 18 minus 7x minus 14. You see it, right? That's the way you're supposed to remove the bracket. Equals to 1 over 6, okay? And now you see things cancel out. So it's basically negative x, and what is that? And plus is plus, let's see, plus 4. You see it, right? Yep, plus 4. Okay, it's equal over 42, okay? It's equals to 1 over 6. So you can rewrite that, but it's okay. So we'll cross multiply. We'll say 6 times, now I rewrite it. 6 times 4, you can write it like this. 4 minus x. It doesn't really matter. Equals to 42. See that? So you multiply that out. That would be 24 minus 6x is equals to 42. Alright? Okay, so that will be 24 minus 42 is equals to 6x. Just move things around how it's convenient for you. So it doesn't matter where you move it. You can still move it back. I'm talking about the variables. Even if the variable is on the right, it's okay. We'll move it back, when we're done. Alright? Okay. And then we'll do 18. Negative 18 is equals to 6x. X is equals to negative 18 over 6. You see what I'm saying? You can do it like that. It didn't break any rule. Alright? So that's actually negative 3. So x is negative 3, okay? Alright, it didn't break any rule. They are doing it like that, So I don't think we missed anything. Let me see. I don't think we missed anything. We did everything right. It doesn't involve too much writing, man. Look at that. Keep writing all the way. Anyway, we're done with that. Okay. Look at problem number 11. It's not that difficult. We've done similar stuff before. So look at it carefully. You see on the left side, the two rational expressions that has they contain variables in the denominator instead of in the numerator. Okay. So what we do, we're gonna have to try to combine those. Let me see. We'll try to combine those into. Notice something though. Look at the second rational expression with 2 in the numerator. We can write it like this. Watch this. This is 3x minus 1. Yeah, you're always looking for something to simplify. See that? X minus 1. You see it, right? Look at that. You see, look at that. You see that? So then that tells me that if I can get 4 on the other, in the denominator of the other rational expression, then they will have the same. Actually, no. Let me see. Hang on a minute. Look at this. This will divide this out. So you got 3x minus 1. You always want to simplify as much as you can. 1 over 2x minus 1 equals to 7 over 2. Okay, so I need to get 2 on the other side. So then I can do 2 over 2 times this side here. x minus 1 plus 1 over 2 x minus 1 here, okay, equals to 7 over 2. If I do that, they will have the same denominator, okay. I'm gonna run out of space, so would I have 2x minus 1, okay. So I multiply the other one out, you get 6 plus 1, okay. See that, right? So there are several ways to solve the problem. You choose whatever way you like. Okay, so you see, I was able to combine them. Look at that. Now you can cross multiply, right? You cross multiply, you got 6 plus 1 times 2 equals to 7 times 2x minus 1. You see that, right? So we simplify, we get, actually that thing is 7. Okay, so 14 is equals to, yeah, that thing up there in the numerator should have been 7, but it's okay. So we do that, we get 14 equals to, over here, 14. Actually, let's do it slowly. Let's remove the bracket first. 7 times 2x minus 2, okay? And then it's the same thing as 14. We could have done it the other way, but it's okay. 14x minus 14, okay? So see the same thing as I see. See, we bring 14 over plus 14 is equals to 14x. I see. You see what is going on? So let's word this up. So that's basically x is equals to 28 over 14, which is, I think, is 2. You see it, right? So there's nothing else we can do. X is equals to 2. So move on to problem 12. You see problem 12 there. We've seen stuff like that. See. So if you look at it carefully, notice that there are 3 rational expressions. 2 of them has variables in the denominator. So we'll try to move those with each other, move it together, and move the other one that contains just constant in the numerator and denominator. We'll move it away from, we'll isolate that one, okay? So that's the best strategy I can see here. So we'll write the problem like this: 2 over x plus 3, okay, minus 5 over 4x plus 12, okay, is equals to minus 3 over 8. Okay, so you see that, right? Now we're gonna work our magic. Notice what is going on the rational expression with 5 in the numerator. We can see the denominator. We can pull out 4, so it becomes 2 over x plus 3 minus 5. Pull out 4, you get x plus what is that, 3. You see what is going on there? Minus 3 over 8. Okay, you see that you see now we can see what we need to do. We need to find a way to get we're gonna get 4. We have to get 4 on the other side, and the denominator of the other rational expression, okay? So we'll do that by multiplying it with 4 over 4, okay? So we say 4 over 4 2 over x plus 3 like that. Okay, we'll multiply like that. Alright. Okay, you see what I'm doing, right? Multiply that out, you get 8 over 4 x plus 3, right? Minus 5 4 x plus 3, like that. I'm gonna see something. Do you see something else? Suppose now we multiply the whole thing by 4. You see, we couldn't have done that before, but we can do it now. Multiply the whole thing by 4, see? The whole damn thing. You multiply the whole damn thing by 4, what do you get? You get 8 over x plus 3 minus 5 over x plus 3 equals to negative 3 over 2. You see it, right? Okay, so we'll combine the left side is x plus 3, 8 minus 5 is equals to negative 3 over 2. See how we reduce the you see how we reduce the problem, right? We actually reduce it to a manageable. We reduce it to manageable size right there. See, and then we'll say it's 3 over x plus 3 equals to negative 3 over 2. So we'll cross multiply. What do we get? We get 6 is equals to negative 3 times x. Okay, we're gonna run out of space. Let me see, let me move it over here. Do me a favor, let me move it over to the right side. We'll move it over here. Okay, we'll start right there. Okay, we'll have 6 is equals to, we'll multiply that and add negative 3x, negative 9. Okay, and then we'll move 3x to the left equals to negative 9, negative 6. Okay, you see it, right? Okay, that's the same thing as negative 15. 3x equals to negative x equals to negative 15 over 3. X equals to negative, let's say negative 5, okay? That's what we're looking for. I think we did it right. We didn't make any mistake. Okay, look at it, number 14, okay? Notice that this is a difference of square like that. So we're gonna expand that to see what else we can see that will help us. X over x minus 4 equals to negative 8. We expand that in x plus 4 and x minus 4, okay? When you expand it, that's what you get. My pen is writing too much, okay? Anyway, we'll expand that. Notice that and that are there. Okay, so we can go ahead and to get rid of, we can multiply with those two things, okay? X plus 4, okay? X minus 4, we'll multiply the whole damn thing with it. We'll multiply this 1 over x plus 4 plus x minus 4 equals to negative 8 x plus 4 x minus 4. We'll multiply the whole thing there. What do we get? Watch this, man. Okay. Okay. So we'll get, I'm gonna push that thing inside the big bracket, okay? Notice that whatever you have on that will cancel out one of them up there. So then we're gonna have, we're gonna get that, okay? All right, yeah, once you push that in, we're gonna have that, because that will end up canceling out that thing there. Sorry about that. That thing will cancel out, that thing will cancel out. Okay, and then we'll end up with that. Let's just simplify that. X minus 4 plus x squared plus, what is that, 4x equals to negative 8. All right, so what is that? Let me see. That is 5x, let me see, actually x squared plus 5x, right? Let me see, yeah. X squared plus 5x minus 4 is equals to minus 8, okay? Let's bring minus 8 over. That's interesting. X squared plus 5x. Bring minus 8 over, then you get plus 4. You see that, right? Then you get plus 4. It's equals to 0. So we have to, can you believe that? We end up with quadratic equation to factorize. We can factor that, man. You know, we dealt with, if you haven't watched my video on quadratic equation, go and watch it. There are many ways you can factor that. You can use the quadratic formula, you can use completing the square, or you can use what they call factoring method. I like to use factoring method because I started using that when I was young. You draw something like this, see that, you put it in there, you split it up like that. X times s is x squared, okay? We took care of that. And then look at the right hand side, look at the constant. You see, we're dealing with binomial. The constant term is 4. So you say, what are the multiples of 4? When you multiply them, you get 4. That's 2 times 2 is 4. And you gotta take care of the positive number too. 2 times 2 is positive 4. But that won't help us, because we also want that the factors to add up to that. So 2 times 2 is 4, but it doesn't add up to, it adds up to 4, it doesn't add up to 5. So that we use 4 and 1. 4 times 1 is positive 4. 4 plus 1 is positive 5. You see that, right? So then the factors are this. That's how we'll factor that. Then we'll say, I don't want to run out of space. Then we'll say the solution to this equation here is x plus 4, x plus 1 is equals to 0. So we get x plus 4 equals to 0, or x plus 1 equals to 0. Do you remember that? We did a lot of this. Go check out my video on the quadratic equation. And then we'll have x equals to negative 4, or x equals to negative 1. Notice one of them will not be the solution. That's what normally happens. Look at what we were given. If x is negative 4, right? What's going to happen here? What's going to happen here if x is negative 4? Then you're going to be dividing with negative 4. Let me see. Yeah, if you put it here, you're going to be dividing with 0. See right here. If you put it there, negative 4, you're going to be dividing with 0. So you can't have that. So negative 4 is not a solution. What of negative 1? If we put it any place here, you're not going to be dividing with 0. See that if you put it here, you're not dividing by 0. You put it here, you're not dividing by 0. You put it here, you're not dividing by 0. So the solution that works is x equals to -1. That's the solution we'll take, okay? I'm glad we'll solve this problem because you see all kinds of stuff. You know, when you simplify the stuff, you end up with a bunch of stuff that look weird, man. But in this case, we'll solve it. So the solution is x equals to -1, okay? Okay, here is our next problem. It's almost similar to the one we just did, okay? Yeah, it's similar to it. I don't know why I chose similar things. Because if you know how to solve the other one, you should be able to solve this one. But it's okay. We'll solve it. Notice that here is a difference of square, okay? Because you can write it like this. Alright? So let's expand that and see what we can do. 3 over x plus 3 minus 2. Okay. Minus 2 over... Actually, subtract this over here. X 3 equals to then -12 over x plus 3 and x minus 3. You see it there, right? Notice it's like the first one we did. So the best way to proceed, we multiply with this. X plus 3, x minus 3. You multiply that, it will clear a lot of stuff. So after you do that, what do you get? Notice that these things will stop dropping off. The whole thing will drop off. Okay, so what drops off here? The positive one drops off. So you get 3 times x minus 3, okay? Negative. And then this -1 drops off here. Then you get 2 times x plus 3, okay? And then both of them drops off. You get -12. You see that? So let's just simplify by multiplying things out. You get 3x minus 9. You get -2x plus... No, it can't be plus. It has to be negative, yes. Because you gotta put the negative inside. And -6 is equals to -12. You see that, right? So let's simplify. We'll have x. I hope we did everything right. X negative, let's see, what is that? 15 equals to -12. You have x equals to, you see that, right? We're moving on. -12 plus 15. What is that? That's 3. So x is equals to +3. Would that work? Look up here, will it? No, it won't work, man. Because if you put that here, it will make that equal to 0. So that's nothing we can do. We did it right, so there is no solution. There is no solution. Because it will make if we put that up there, see? If we put it up here, that's positive. If you put it up here, it will force you to divide by 0. Even here, if we put it here, it force you to divide by 0. So the solution set, another way to say the solution set is empty set. That's how you write empty set, or you can write it like this. Solution set is an empty set. That's all we can do, man. There's really nothing else we can do. Right, here is the next problem number 16. Notice it's almost similar to what we did before. Notice here, this is a difference of 2 squares. Okay, see that, right? So let's just expand it, and then we're gonna do the same thing we did before. We'll have x over x minus 3 plus 4x plus 3 equals to 18 over x plus 3 and x minus 3. See? Okay, so now we're going to multiply this with this. We're going to do the same thing we did before. Let's multiply that then out. We'll multiply the whole damn thing out with this. X plus 3 and x minus 3. Okay, so things will start canceling out. Alright, see the first one, the x minus 3 will cancel out, then we'll have x plus 3 times the x, okay? And then we'll have the other one, x plus 3 will cancel out. You see that, right? Yeah, x plus 3 will cancel out, so you get 4 times x minus 3 is equals to, notice that the whole thing on the denominator will cancel out, so it equals to 18, okay? So we'll simplify the left side. What do we get? We'll get x squared plus 3x plus 4x minus 12 equals to 18. You see that, right? Okay. So we keep going. We got plenty of space. It becomes x squared plus, actually no, it's not gonna be plus. We gotta be careful. I don't want to keep writing stuff all over. If you add this together, what do you get? Yeah, actually it's gonna be plus. It's plus 7x, and then this and that. What do you get there? If you bring 8 to the left side, it becomes negative 18, right? Then so you get negative, what is that? Negative 30. You see that, right? The whole thing is equals to 0. I hope I didn't go too fast, you know. So, but anyway, this is a quadratic equation we gotta solve. Alright, we'll solve that quadratic equation. Again, I have a video on that. You solve it any way you want. You can solve it using the quadratic formula. You can solve it using the, what they call, completing the square. Or you can solve it using what they call factoring. Factoring is this. You go like that. You put x here, this one here. X times s will give you that, x squared. Now, we want two factors such that when you multiply them, they will give you, they will give you 30 and negative 30. If you add them, they will give you positive 7. You see that, right? Okay, what do you think will the factors that can do that? What factors do you think that can do that? Well, let's try. Whenever you have something like that, 30, 40, 50, you try 10 times 3, okay? One of them gotta be negative. Let me see. Remember, this is positive here, so this gotta be negative here. Because if we put 10 here, negative 3 here, when you multiply, let me do it for you. I've done this many times in the past. 10 times x, you get 10x. Minus 3 times x, you get negative 3x. When you add them, what do you get? You get 7x. You see how we got that? Okay, but I'm gonna wipe that out. That way you can see, you know. So that our factors are this, and that. You take it like that. So basically our factors are x plus 10 and x minus 3 equals to 0. That's how we solve that. So it's x plus 10 equals to 0, or x minus 3 equals to 0. X equals to negative 10, or x equals to 3. Now, one of them will not work. Go back to the original equation. If you put x equals to 3 here, you put x equals to 3 here, you will divide them by 0. You put it here, you divide them by 0, man. So that means that we discard that. That solution will work. You discard that. So the only thing that will work is that. Okay? I hope you understand the logic there. That's how it's done. Then you say x equals to negative 10 is the solution we're looking for. It will work. You see that, right? It's nothing anybody can do. That's how it goes, man. So the solution set, if you want to do by the solution set, another way to write that solution set, okay? Solution set, that's always a set. Solution set is negative 10. That's all that set contains. It's not an empty set. It contains something. The solution set contains something in it, and it's negative 10. In case you don't, that's another way to write that, So, but anyway, we'll move on, man. We're done with that. So this is the next one. Okay, here is our next problem, number 17. Okay. Let's see. Look at that carefully. Notice that a lot of stuff can be factored. That will start from the left. 4 over 3 x plus 2, right? Okay, negative 3 x plus 3 equals to, notice that we can factor that out too. We can factor the denominator at 8. Okay, so we do x 3 and let me see, 3 and 2. Yeah, 3 and 2, positive 3 and positive 3 and positive 2. Yeah, it will do the job. Yes. So we'll have x plus 3 and x plus 2. Okay, that's how you factor that. Alright. Okay, so then what do we do? Well, yeah, I can see. Let's multiply. Let's multiply the whole thing with that. With what did I do? Yeah, we multiply the whole thing with. Oh, I see. Hang on a minute. Let me think this through, man. Notice we have to multiply with that, combine with that, combine with. Let me see that. Notice that this side has both things in there, so it will work. So let's move on. We'll multiply like that with 3x plus 2 times x plus 3, like that. Multiply the whole damn thing like that, because it will cancel a bunch of stuff out. Okay, so when we multiply, what do we get? We get 4 times x plus 3, right? Yeah, because he canceled that down and canceled 3. Okay, negative. We multiply that. What do we get? You get 3 times x plus 2 times another 3, the 3 on top. Okay, that's what you get there. It's equals to, multiply this one out, you just get 8, because actually you get 8 times 3, because those two things in the denominator cancels out. They cancel out. So let's simplify. You get 4x plus 12 minus 3x. Well, let's do 3 times 3 is 9. So we'll just go straight. 3 times 3, that is 9. We say 9 times x is negative 9x. 9 times 2 negative, because negative 18. Okay. Yeah. Okay, it's equals to 24. See? That's what we got there. So we'll simplify. We'll keep simplifying further. I'm gonna do right. We'll move stuff to the right and leave the variables to the left. We'll have 4x minus 9x is equals to 24. Sometimes I do it in my head, plus 18 minus 12. You see that, right? So basically you have minus 5x is equals to, do all that. If you do all that, what do you get? Do all that stuff there. You get 24 plus 18 minus 12. You get 30. So it's x equals to negative 30 over 5, which is negative 6, right? That's what I got. So I think it's correct. We didn't make any mistake. So that is correct. So x is equals to negative 6. That's what we can say. We'll move on to the next one. Let's move on to this one here. Okay, you see that? That's the next one. Notice that, look at it carefully. You see that? That is in here. Because if you factor that, you get that. So let's expand it. We'll see x plus 2 plus 1 over x squared minus 2x plus 4. Factor that, what do you get? 24. You get x plus 2 and x minus 2 raised to the power 2 minus 2x plus 4. You see that, right? We did that. I think I covered that in the other video. Okay, notice what is going on there. I think it's not clear there. Let me make it clear. That's 24. 24 right here. Okay. All right. Now notice that we can then multiply the whole damn thing. We can multiply the whole thing with that. Actually, that combined with that, because that is there. That's there. That's there. And this one contains both of them. So we'll multiply with x plus 2. Okay, x squared minus 2x plus 4. Okay, you multiply that, what do you get? Things will start falling off. Okay, 2x squared minus 2x plus 4. Alright, plus that thing will fall off. You get x plus 2, okay, equals to, that thing will fall off. You get 24. You see, everything on the denominator will fall off. So you multiply this out, you get 2x squared minus 4x plus 8 plus x plus 2 is equals to 24. We keep simplifying. Let's simplify more. Let me see. What do you get there? Now, just give me a minute. You get 2x squared minus, what is that? 3x. Okay. Alright. Okay, bring 24 over, minus 24 plus, what is that? 10. So equals to 0. This is a quadratic equation. 2x minus 3x minus 14 equals to 0. You see that? You see that, right? That's what we got. That's what we got right there. So we'll have to factor. We use that. Well, here you can use whatever you want. You can use the quadratic equation to factor it if that's what you want. You can also complete the square if that's what you want. But I prefer to do factoring. It's a little faster. And look at 14. 7 times 2 will give you 14, right? 7 times 2. Alright, 7 times 2. Okay. Actually, that's not all of it, because you got 2 here. We didn't get rid of. We could have gotten rid of that too. We didn't get rid of it. So it's 2x over here and x over here will give you 2x squared, okay? So 7 and the 2. If you put negative 2, make 2 negative, you get negative 14, right? So suppose you multiply negative 2 times 4, because we're multiplying like that. You get negative 4x. And then, yeah, it will work. Let's put negative here. I'll show you. 7 times x is 7x. Negative 2 times 2x, you get negative 4x, okay? You add those together, what do you get? You get 3x. That's what we're looking for. Actually, we're looking for negative 3x. Hang on. I have to change something. See, that's how you do it. We're looking for negative 3x, okay? Actually, here, negative 3x. So let's say we do 714. It's not gonna work. All right, just give me a minute. Let me think through this, man. Yeah. It's nothing to think about. Switch the negative sign. I'm just getting tired. Let me show you. You switch the negative sign, okay? Put 2 here. Put negative 7 there. Then negative 7 times 2 will give you negative 14. But then you get negative here, right? Negative 7 when you multiply like that. When you multiply that, you get positive 4. When you add them, what you get negative 3. So that will work. This worked. Okay? So let's clean house a little bit. Alright, so we got what worked. So we'll have 2x minus 7 times x plus 2 is equals to 0. I'm sorry, going too fast, man. 2x minus 7 equals to 0, or x plus 2 equals to 0. Okay? Alright. So let me see. X is equals to 7 over 2, or x equals to negative 2. One of them may not work. Let me see. Yeah, if you put negative 2 here, see, you divide with 0. You see that, right? So negative 2 won't work, man. You cancel that. So the only solution we'll have is that. You see that, right? That's the only solution we have. 2 cannot. Negative 2, x equals to negative 2 will never work. So our solution x 7 over 2. That's all we need. So that's it. Okay, here is our next problem there. Problem number 19. So you see, it's getting complex. I'm making it more complex and more complex, okay? Look at that. You gotta see. Look at that in there. Factor that. I think this will be in there if you factor that, okay? So let me factor that and find out. Okay, yes, if you factor that, you get that. By the way, you know how you factor that? You write like this, 3. Then what is that? 3 raised to power 3. Okay, sorry. It's 3 raised to power 3. And then you say x minus 3, like that, x 2 minus 3, 2. You see that, right? So you keep extracting that. See, that one is this one here. Okay? You know, that's difference of squares. You know, so but anyway, that's how you do that. Don't worry about that. So if you factor that, you get that. So then that means, let's rewrite this. We have 2. Oh Lord, I'm writing with red pen. Right there we get 2 x minus 3 plus 1 over x squared plus 3x plus 9. Okay, it's equals to 54 over x okay. So you can multiply the whole thing. Notice that that is there and that is there. You multiply the whole thing by, that's the LCD, right? What is that then? X squared plus 2. Okay, multiply it with that, because that will start canceling things out. So the first one there will give you 2x squared plus 3x plus 9. Okay. The second one there will give you, that thing will cancel out, x minus 3 equals to, that one will only give you 54. Okay, you see it, right? So that's what normally happens when you start canceling things out. That will happen like that. Okay, let's expand things. We need to expand stuff. Yeah, let's expand this stuff. We expand it, we get 2x squared plus 6x plus 18 plus x minus 3 equals to 54. Okay, so we'll combine stuff and move stuff the other side. We'll get 2x squared plus 7x plus, well, we actually won't move everything to the left side, okay, because that's what we want. Okay, so we'll move things around, we'll get that, then we'll simplify 7x is a minus 39 is equals to 0. You see that, right? So now we'll have a quadratic equation to solve. Again, you solve any way you want, any way you prefer, your preference, you solve it the way you prefer, okay? You can use a quadratic formula, you can use completing the square, or you can do it the way I do it. This is the way I do it right here. So I use factoring, the old traditional way of factoring stuff. I go like that, I put 2x here, I put x here. Both of them multiply will give you that. Now I'm looking for factors of that. That will give me negative 39, and when you add them, they will give me plus 7. Notice that I have to put that into consideration, okay? So the thing that will work, I checked it, the stuff that will work is 13 and negative 3. Notice that if you multiply 13 and negative 3, okay, you get negative 39, okay? But then when you multiply across like this, you see, you get 13x, and here you get negative 6x. When you add that and that, what do you get? You get negative, let me see, what do you get? Yeah, you get 7x. Yes, you see that, right? So these are our factors right here. So our factors are 2x plus 13 and the x minus 3 is equals to 0. You see it, right? So let's clean house, make it a little cleaner. So those are the two factors we have there. So basically it will be 2x plus 13 equals to 0, or x minus 13 equals to 0. So that's see the same thing as x equals to negative 13 over 2, or x equals to negative positive 3. We usually don't write positive 3, we'll write it 3, but notice what's going to happen. One of them will not work, because if you see x equals to 3, if you put it here, you'll be dividing with 0. Alright, you see that, right? So that won't work. This one is discard that one, it won't work. So the only solution we'll have is this one here. Okay, so that's the only solution we'll have that will work. Okay, all right. Okay, here is our next problem. It's a little lighter. Okay, so let's knock that out. This is number 20. Okay, look, eyeball it. You see what is going on there. They have look at there are three rational expressions, right? And then what you see there is just give me a minute. What you see there is the two on the right hand side have the same denominator, right? So we can combine that. Notice that the one on the left, this one here, we can write it like this. We can expand that. Let's expand it first. It's x plus 1 and x minus 1. Okay, so that's equals to 2x minus 1 minus 1 x minus 1. So then we can multiply the whole thing. That tells us we can multiply the whole damn thing with this. X plus 1 and x minus 1. Okay, you multiply that, what do you get? Things will start canceling out. Alright, you get, let me see, this entire thing will cancel out. You get 1 equals to 2x plus 1, okay? Negative another 2 is x plus 1. Okay, yeah, x plus 1, sorry, there's no denominator there because that thing cancels out. X plus is that yeah, x plus 1, but don't forget it's in bracket. This is subject to that negative sign there. Okay, so we simplify. We have 1 is equals to 2x plus 2 negative x negative 1. Okay, keep simplifying. We'll have, I'm gonna move, well, it's okay, we'll leave it like that. 1 is equals to, look at that and that. It's x and that, x plus 1. Okay, you see that, right? So then that gives you x is equals to, oh Lord, if you move that over there, it becomes 0. X equals to 0. What the hell? I mean, that's what it gives us. X equals to 0. If we, yeah, it will work. Because if we put it in any of that stuff, it will not cause any of them to be 0. You see? So x equals to 0 will work. I don't see any problem with that. So that's our solution there. So if you want to say solution set, another way to say the same thing is this set has 0 in it. That set is not empty. The element in there is 0. Okay, so let's do the next one. We'll knock it out. This might be the last one. That way we can see. I may change my mind. We might do application in another video. We just, in case I'm tired, maybe we'll submit this video like this and then we'll do application later. Okay, all right, let's knock this out. The same thing. See, the same thing like we just did. Notice that this stuff here can be written x squared minus 3 squared, difference of 2 squares. Okay, so we expand it, we get 3 over, just give me a minute, I'll check something. Okay, so we expand it, we get x plus 3 and x minus 3. Okay, That's what we get there, equals to 3 over x minus 3 minus 2 over x minus 3. Now notice that we can multiply the whole. We can combine the right side, but that's okay. Yeah, we can actually combine the right side if we wanted to. But we can also multiply the whole damn thing. Let's multiply it. We'll make things disappear. X plus 3 x minus 3. Okay, we'll multiply with that. And then what do we get? We get 3 because this disappear. And then when this one will disappear, we inherit this one. So it will be 3x plus 3. Negative. This one will disappear from there and we'll inherit this one. Okay, again. Negative 2x plus 3. Okay. Alright. So we'll expand stuff. 3 equals to 3x plus 9. Okay. Negative 2x, negative 6. Make sure you understand why, because this negative sign is outside that bracket. Okay, so we'll combine stuff. Let's combine stuff on the right hand side and then we'll see what happens. We'll get x plus 3. Okay, oh, the same problem again. It's x is equals to 0. Again, man. That's what we get again, man. It's nothing else we can do. That's what we got. It's nothing we can do, man. So the solution set. The solution set got one element, okay? The element in there is 0. So that's the solution right there. It's not an empty set because it got an element. The element is 0. You understand, right? So let's leave it there. Please subscribe to my channel, like and share this video. If you have any comments or question, leave it under the video. I will answer them as soon as I can. Thanks for coming. Happy New Year. What I will do, I will look at the I'm gonna look at the applications of this rational expression, and then maybe I'll make another video because this video is so long now. So I'll make another video on that. It may be a short video. I don't know. I haven't decided. Okay, thanks. See you later.